piece around it was backwards. Like, this doesn't make sense how this is set up on here. Well, my clock says it's 11:30, so I guess I'll go ahead and get started. So my name is Lance Albertson. I'm the director of the Open Source Lab at Oregon State University, and hopefully you're here to hear about what we are doing there at the Open Source Lab. So kind of a session overview. Going to give you the overview of the lab in case you hadn't heard of us. Talk about OSL students and our alumni, what they do while they're at the Open Source Lab, and their experiences. And then I'll go through a set of current and new services that we've done over the last couple of years, and also talk about some infrastructure enhancements we've also done, and also talk about some goals we have in the next year. Feel free to ask me any questions at any time. I have a lot of content on here, so hopefully I'll be able to get all through it. So how many of you have heard of the Open Source Lab before? Okay, so all of you have. Okay, so I don't have to go through that. For those that haven't, though, but we're basically a free and open source software hosting company is what you can think of us as. We provide free or low-cost hosting for open source projects from around the world. We provide anything from co-location to virtual machines. We also have access to a lot of variety of architectures. We've been expanding that quite a bit. I'll talk about that more later. And we also are pretty popular with our software distribution and mirroring with our FTP cluster, which has been pretty popular. The other part of it is, and that maybe isn't as well known, is the mentoring of undergraduate students we have in DevOps and open source. So all of our students, all of our students get real-world experience while they're in college dealing with production software. Some of our past graduates were even the co-founders of CoreOS. So we have a lot of impact in the industry. And many of the others have key roles in the tech industry and or even here at the conference. Lucy, right here, is one of our students. She works at Puppet. Currently, our staff is me. I'm the only full-timer currently. We used to have a couple more full-timers, but with some funding, which I'll talk about a little bit later, difficulties in the past few years, I had to unfortunately cut back. But we're still doing the great stuff. We currently have 6 to, right now, actually 10 undergraduate students. We just hired 4 new students the last couple weeks. So bringing them on board and getting them going. So some history. We started back in, well, officially we started in 2003. Unofficially, it started about 2002, I would say. I always go based off of when OSUOSL.org was registered, which was in October of 2003. It was co-founded by Scott Kavitin and Jason McCurr. Jason McCurr is, I think he's still the VP of Engineering for Ansible, I think, at Red Hat still. But he's been through a lot of companies, and so has Scott. He's gone through a lot of things over the years. But they both worked at OSU at the time under information services, and they had connections with the open source communities. And at that time, the cloud didn't exist. Hosting your open source project was basically SourceForge, or you hope somebody had a server somewhere. And so we came out of the blue and helped with that. And in the beginning, we offered co-location servers for a bunch of projects. Initially, it was Gentoo Linux, Debian, and Freenode. And then from there, just spread through word of mouth. For several years, we hosted several of the services for kernel.org. We host currently most of the Apache Software Foundation, Drupal, some of the Linux Foundation, and many, many more. I actually have a slide that has all the various projects. But it just grew from word of mouth. And once that started happening, the leaders at OSU at the time, in case you don't know, Oregon State is a land-grant institution, which is a special designation in the United States. It basically is its mission, part of its mission is extension and outreach to the community of Oregon and beyond. And so what we did at the Open Source Lab was convince not only the CIO at the time, but also the current president of the university, that we are an extension of that in the 21st century. And so we've gotten a lot of support, at least not so much financially, but we did initially. But that's where a lot of that support happened. And so we got some initial funding from some savings that the university had with switching to open source software. And then we also had some initial funding and continued funding from Google. And then we got a really nice big donation from Real Media. How many remember Real Media back in the day? Yeah. So that's kind of how we started. And we also tapped into some dark fiber that was post.com boom up and down the I-5 corridor, that they had some infrastructure upgrades. So we suddenly had bandwidth that we could use, which was kind of hard to do at the time. Over the years, we've had some organizational changes. We eventually moved over to an academic unit. We're now under the College of Engineering, under the Computer Science Department. We created a more overarching unit called CAS, which stands for Center for Applied Systems and Software. And we actually partnered with some other organizations on campus that were doing similar things. There was another group on campus called Business Solutions Group. They did a lot of software development. At the time, they were doing a lot of .NET. Now they're doing that plus a lot of things. And they also had a big testing group there as well, and we still have that. So if you're interested in testing software, I can help get you connected with that group. So we've had a lot of organizational changes over the year, but that's kind of the quick history. Our funding model is the hardest part. That's what I try to do every single day and make things go. But most of our funding comes from corporate donations. Over the years, our big primary sponsors have been IBM, Google, and Facebook. There have been other sponsors over the years throughout that. We also have some hosting contracts for some of the larger projects. So we actually have a hosting contract with the Linux Foundation, Drupal, and the Open Source Robotics Foundation. That helps cover some of the cost. We obviously can't compete with the public cloud, but it helps cover the bill, so to speak. And then from there, we also get in-kind donations for hardware. In the case of TDS, they provide bandwidth donation for 2 of the 3 FTP servers that we have. In recent years, we've gotten other hardware donations from Intel, Facebook, and more recently Hudson Trading. And obviously support from many of you who individually contribute. We are the Open Source Lab is underneath Oregon State, but we're also part of the OSU Foundation. So if you want to give us, if you want to donate any contributions or money, you can go through the OSU Foundation, and it's a 50C3, and go through all of that. We currently get no direct funding from OSU or the state of Oregon. We obviously get the kickback of being a part of the university and being a part of the system, but that's basically our funding model. And this is a constant challenge every year, so it's fun. And this is kind of what I see our role in the FOSS ecosystem: provide a neutral hosting facility. That kind of helps also foster relationships between open source projects and businesses. One of the big examples is IBM, and I'll talk more about that in a little bit. Also provide a stable physical home for the core of open source software. Whether that means free hosting. A lot of these projects, at least some of the older guard, as I would want to say, they rely on a lot of free hosting from a lot of companies. A lot of the other places, they have a hard time managing that hardware if something happens and so forth. And maybe the hosting company gets under different leadership, and so they don't have that hosting anymore, and so they have to shuffle around. So we provide that stable home of, we're here, we're part of the university, we don't have any direct ties to any corporations, and so forth. And the other thing is that what we do is we're flexible to the needs of the projects as much as we can be. We try to do what they need to have. The other thing we have is we have access to unique hardware and architecture. So we've been really big in the open power with the PowerPC. We've been doing a little bit of ARM. We don't quite have RISC-V yet. That might be on the roadmap, but we are doing a little bit help with that architecture. We have some MIPS and anything else you can think of. We probably have a version of that system at the lab. I also view us as having the ability of providing compute and storage resources, whether it's at software mirroring. Some newer stuff that we've been doing is dealing with continuous integration and continuous deployment with open source projects. We also provide systems engineering expertise to a lot of these projects. Many of these projects, they're not sysadmins, they just, or DevOps people, they just write the software and they need to have it hosted. And especially before all the cloud and all the other fancy services we have these days, that was really needed. So we've been helping with them with that. And the other part is training the next generation of open source leaders, like I mentioned. So we have a lot of influence. So here's just a list of some of the projects that we've onboarded in the past year, including a little bit in this year. So on the general hosting front, we brought on, a variety of projects. We're actually in the process of bringing on the personal tech code project. That was another example where they had their physical server hosted somewhere, and the company got new management, and they're getting kicked out, and they're like, hey, can we bring it down? I'm like, yep, sure, there we go. We can keep that project going. Some of these are just FTP mirroring. Some of them are actual physical hosts. Some of them are just VMs. It's just kind of a splattering of that. In the past couple of years, we've gotten a whole bunch of other projects added to our list, mainly from our collaboration with Open Power and our IBM system. So I wanted to kind of separate all that. So all of these projects listed here have some kind of virtual machine running on Power that they're using for either test integration, builds, or something. And these are just the new ones in the past year that we brought on board with that project. So it's quite interesting. And then I get into this fun little slide I made this morning. This includes every single project that's either mirrored or through the Open Power, as a VM, has a website. Somehow we host something for them. Might be a small little thing, it might be a huge thing. But we have, the count has gotten almost to 200 projects. And that doesn't count the sub-projects that a lot of these organizations have. So like the Linux Foundation and the Apache Software Foundation have hundreds underneath that we obviously are helping. This is obviously a constant challenge of keeping up with all these projects and their needs and what they're doing. We're currently in the process also of making sure that all the projects that we are currently hosting are actually still using the resources, or if they've moved on or something like that. That's always a constant problem too. So now let's talk about the OSL students. So let's talk about alumni. How many of you have heard of CoreOS? Okay. The two people that founded it, Alex Polsey and Brandon Phillips, were some of the first students at the Open Source Lab. And they actually had some prior startups that they had done. We also have a lot of alumni working at the Linux Foundation on the infrastructure side. Sarah Cooley, who's here at the conference, she's been at Microsoft for many years. All the Linux subsystems that you've gotten out of the Windows side of things, she's touched her hands on and been a part of that. So that's really, really cool. And then we have students that are now working in all variety of different places of companies. Over the years, we had a lot of people go through Mozilla. We have people AWS, Puppet, Apple. We just had an alumnus come from Tesla. He just moved there, and he's working on some of their big, the battery stuff that they're doing, the big power stuff. So lots of people in the industry out there. Very influential. Now, while at the lab, they basically act as kind of like help desk for the open source projects, and they also do a lot of other things. So day to day, they're interacting with open source projects, whether that's through our ticketing, IRC, Slack, you name it. They troubleshoot stuff, they deploy websites, they onboard new projects. We're a chef shop, so we do a lot of stuff in Ruby. So a lot of our students are learning how to make cookbooks, maintain them, dealing with legacy code, new code, dealing with that constant thing and actually seeing what happens when you get something and you're like, oh, this is how I now have to manage this. The hands-on experience, which oddly enough has gotten to be a lot harder, especially on the physical server side, with everybody using public clouds. A lot of DevOps engineers have never actually touched a server before, like an actual server. So we actually give them an experience of saying, here's what it would look like in a data center somewhere, or maybe even a cloud provider. So they get experience installing and even uninstalling. We're going through a phase of trying to get rid of some older hardware, troubleshooting real-world problems, and also dealing with the weirdness that you have when you have physical hardware. We currently have a system right now where we have a support ticket queue, and we just have a round robin of students. And so each week, a student gets assigned to be on that rotation, and then whatever new ticket that comes in that week, they get it. They automatically get it, and then they work on that. And that really gives them the ability to have an understanding of how all the various parts of our organization work. Since we rely on students quite a bit, it's really hard to keep track of all of that. Hiring process. We have an open book quiz. We ask them some basic Linux questions, some simple bash exercises, some chef exercises, simple stuff to kind of, if they're really interested in working for us, we want them to actually, you know, take some time and do a little bit. We're not doing a huge ask for them. We're not making them write a whole project, but enough to like, can you find some stuff on Google, deploy something, or like at least try something and at least show that you've tried to do something. Most people do pretty well on that, and then we just move on to an in-person interview. It's a wide range of questions. We've refined it over the years. Some of them are probably questions you would ask on your own full-time hiring. We always tell them at the very beginning, hey, we don't expect you to know all the questions or know the answers, but we want to at least see how you're going through and doing troubleshooting. And so that really helps us assess, like, are they going to be able to tackle the problems that we have? Like, are they going to be able to say, like, okay, I know I need to look here, I should ask here, I kind of see how this is going. A lot of the people we bring on have very basic knowledge of everything. And it's amazing how much they learn in such a short amount of time. Once we hire them, we have a walkthrough guide that we're constantly refining. I actually had to make some adjustments this past week. We get their account set up. We get them involved in contributing to documentation early on. We get them going through some basics of Linux, and then the basics of Chef and how we do our stuff. And then we have a very specific Chef onboarding guide. We have a test cookbook that already has problems, and we walk them through the basics of how we do that. We actually have them create a PR and have them go through the normal process that we would have on our production cookbooks, but in a test case way. And it's a great way for them to learn, you know, by example what's going on. And then within the first couple of months, we get them assigned some task initially, and then we just add them to that rotation and kind of get them going. So I always have to constantly fight the problem of, I know that summer's coming, which means I either have some students graduating, or I have some students going on internships, or other. And when they go on internship, it usually goes two paths. Either they come back and they work another year or two with us, or they have an awesome experience and they get a remote part-time job with them coming back, which I'm totally supportive of. And that usually gets them into a full-time position after they graduate. So I have to constantly fight that, which is fun, but it's also exhausting. And summer is the time when we actually get a lot of work done because students can work full-time unless they're taking school up to a certain amount of hours. During the school year, they can only work up to 20 hours a week based off of OSU's HR guidelines. But they can work 40 hours, and we encourage them to do that. So a lot of these new students that we hire, we have to have them in the summer, and you know, we want to be able to complete a bunch of the projects that we want to get done. So that's what we do. So now I'm going to move on to current services and new services we've done. So our managed platform, what we manage ourselves internally, all of our systems are CentOS-based. Currently 7. We have some 6 systems. For workstations, we're actually using Debian for a variety of reasons. Well, gives experience using both distributions, and it has a little bit better workstation support for what we want. All of it's managed through Chef, which also gives students experience of understanding how do I deal with multi-platform support on something, and how much of a pain is that? As I mentioned, everything is in Chef. We have wrapper cookbooks. We use a lot of community cookbooks. I'm constantly trying to open up a lot more of our cookbooks on GitHub, but it's that constant battle of, you know, we have so much site-specific stuff, and we don't want to like open up all our various configuration, but we also want to show the stuff that we have, so we're trying to go through that. The one big reason why we're using Chef is it really offers a nice suite for tests and testing software. Since Chef is Ruby, we can use RSpec or ChefSpec to actually test the code and make sure the code does things, so students understand unit testing and testing of that. And then we can use a tool called Test Kitchen to spin up a VM and converge Chef and actually see what it looks like, converging all the steps and seeing like, oh, these services gets installed and then started up, configuration, permissions, all that fun stuff. And then we tie it in with a tool called Inspec, which I think the Chef folks are having a talk about later today. You should go check out. And that way we can actually test and make sure that everything is set up the way it is. The port listening, the file has the stuff it has. I can run a command and it does what it needs to do. It's a nice environment for students to understand how all these systems kind of fit together. So it's really been good. And we tie it all into Jenkins and automate a lot of the promotion of the cookbooks through our system, which is fun. We still are fighting a lot of legacy systems, as with any organization that's been around for almost 15 years. We have technical debts and systems that Snowflake systems. So we have systems that are still running CentOS 6 and Gen 2, which is what our previous platform was based off of. And we use CFN Gen 2 as our main configuration management, so we still have some of that stuff. I'm hoping we'll get done with that this year. Hardware budget, we really don't have a hardware budget. Most of our expenses go through paying wages and salaries and paying our bandwidth bill. So I can maybe get 1 or 2 servers a year if I really needed it, but we mostly rely on in-kind donations. And we got a nice influx of machines back in 2012, which was a while ago, from Intel. Anybody remember Migo? Probably don't. It turned into something else, and now it's Tizen, which is I think what Samsung has come up with. It was their mobile platform stuff. Well, we got out a contract initially with them hosting a bunch of their Bell servers and so forth. And when that fell through, they're like, well, we don't want the servers back. You can have them. So they split it between us and the Linux Foundation. So we got a nice set of Dell machines. And we're actually using quite a bit of them still today. A lot of our production stuff is still using that. A couple of years ago, we partnered with EMC. This was right before the acquisition from Dell. And they had an OpenStack project called Neutrino, and they wanted to kind of donate some hardware and get some things going. And so they sent us these nice Arista switches and this nice 4-node compute servers, that like a 2U that has 4 servers inside of it. We got 2 of those nodes. That didn't pan out because they got sucked in and all that, but we got the hardware, so I can't complain. So we got some nice hardware out of that. And then around that same time, we also made a connection with Facebook with their Prineville data center and got 3 open compute racks full of compute nodes. And I'll talk more about the logistics of that later, but we finally got that going. And more recently, we've been working with Hudson Trading. The Debian project had some connections with this group through the Debian DebConf. I'm saying, hey, we have some hardware. We're cycling through hardware. Do you need this? I was like, we don't, but I think the OSL might want it. And so they have sent us pallets of Arista 10 gig switches. We're not going to need to use all of them, but it's going to help us out quite a bit, and I'm still in the process of figuring out how we're going to use all of that. So, but I do have a wish list. We need to refresh our aging Dell suite of systems, so we need 1U, 2U compute and storage nodes to kind of replace that. Need hard drives and SSDs, and I really need to have some Indro switches, 40 gig switches, and then some more 1 gig top of the rack switches. I want to we want to do some stuff with that. So hardware's fun for us. Some of the core infrastructure that services that we provide are this typical stuff: mailing lists, email forwarding, DNS. We do a lot of web application hosting, whether that's static, PHP, you name it. Within reason, we can do it. And we also do the systems engineering consulting for a lot of these projects. We have 2 ways that projects can have their systems hosted at the lab. We can either manage it or not manage it. So manage means everything's in our chef. We manage the operating system updates. We manage all the services. We help design the infrastructure. We monitor it. And we also, if the project wants it, we can open up the cookbook and we can do a lot of stuff that way. But it's unmanaged. That's your typical what you do now with cloud. We give you an account. You spin something up. It's on your own. The only thing we really want, at least on some of the more legacy systems, is we want to have an account on the system so that if you have an issue, we can log in and help you with it. Some of our newer stuff on OpenStack, we don't really require that as much, but it really does come in handy. How many of you use our FTP mirrors? Okay, cool. So we have a 3-server cluster. One's in Corvallis, another one's in Chicago, and another one's in New York. They're split via just a simple DNS round robin. The Chicago and New York locations are very nice because they're right at exchanges, really close. So they've got a lot of bandwidth, and that's with the TDS telecommunications. We push about 1.7 gigabits per second on a daily average across all the 3 nodes. We currently have 15 terabytes of capacity, and we're using about 12. That always keeps growing. There's over 100 repositories and projects that we have hosted there. The specs are horrible, or at least on the RAM and the CPUs is way over what we need, but we got a nice donation from IBM a few years ago, and these are actually running on Power 8. They all have 10 gigabit uplinks. Actually, Chicago and New York have 2 10 gigabit uplinks and bonded, so we have more than enough bandwidth that we ever need. So they're nice and beefy and fast. On the co-location hosting side, we have about 300 different servers. This hasn't grown as much over the years, but it kind of depends on the projects and what we're doing. Most of the projects we bring on just need VMs. But some of the larger projects have their own specific racks. So like Gentoo, the Linux Foundation, Drupal, Apache, they all have their dedicated racks where they have their equipment in. Most of the other projects, we have it spread out between a variety of different racks. All these projects own their hardware. We don't pay for it. We just have them pay for it and they ship it to us. But we have some requirements. Over the years, we want to make sure that, first, do they actually need to have a physical server? Is it rack mountable? I can't tell you how many servers we've gotten that has no racks, and we just have to set it on the bottom, and then if we have to put anything on top of it, you can't really do anything about it. We really want to have out-of-band management so that if anything happens, we can log into it remotely. Our office is now away from the data center, so it's even more important. And we want to also make sure it's built by a vendor. We had problems in the past with a couple projects where they would buy, a super micro chassis and put a motherboard in and all this and that. And while I'm all for that, it's a pain in the rear when something goes wrong. So it's nice to have something that's actually built and been tested properly. Obviously, we make some exceptions for some special architectures. There's some architectures that aren't rack mountable, or it just doesn't make sense, and so we'll make exceptions. The data center we have right now was upgraded about 15 years ago, right before we started. It's shared with the university. It's not the fanciest data center. It's nice and clean, though. There's about 70 racks in that room, and we use about 32 of those racks right now. They're not completely full, but that's about the amount of racks that we have. We use that room more than anybody else by a long shot. Storage. We've recently dived into Ceph. In the last year, we've built actually 2 different clusters. We got a donation from IBM to build out an OpenPower-based Ceph stack for our OpenStack cluster, and then I also used some of our spare hardware that we had donated from in-kind and converted it into Ceph as well. Remember all that gear we got from EMC? That came in handy with the 10 gig switches, so I could actually do Ceph in a nice scalable way. So we got that going. On our x86 cluster, it's based on Nautilus right now. Going to be getting it up to Mimic, and then I can't remember the next version is coming out. We're trying to keep up with that. It's about 100 terabytes of raw capacity. We got a nice little donation of NVMe drives from Intel. It's all based on 10 gig networking, which is enough for what we need, and it works really well. On the OpenPower, it's really huge. It's only 5 nodes, but it's got a lot more capacity. They have these 8 terabyte drives they got in there. It's insane. And we also have a 40 gig switch that we had donated from Mellanox that we have these on, and it's very fast and it's very nice. So Ceph has been a very big and new thing that we've been doing, and I've been really impressed with it. And knock on wood, hopefully it stays stable and works for us. How we're using it, our primary users right now is just block storage for OpenStack. We recently just got CephFS deployed as well, and we just migrated about 6 terabytes worth of data off of that from GlusterFS, and now we're all CephFS. That seems to be working well. Hopefully it stays that way. Future plans, I don't know if there's much need, but I think it's probably important for us to start looking at object storage, the help projects. Also, as we need it, expanding, upgrading hardware as we need it. Right now, I think we're okay where we're at, but obviously it'd be nice to be able to expand that. We have another virtualization cluster that's built on Ganeti that's all local storage, and I'm considering moving all of that over to Ceph as well. I'll talk more about Ganeti in a little bit, but that might be a project. And then if we need to, we could start looking at geo-replication. I think it's Ceph mirroring is kind of the terminology they use, so that we have a little bit more resiliency, but everything's working out really well. As I mentioned, our cloud platforms. So we actually run 2 different cloud platforms at the OSL. Our primary one that we have a lot of our production stuff on is Ganeti. I've given many talks at conferences like this in years past about Ganeti. It's a project that came out of Google. They used it a lot internally. Unfortunately, they shifted away from it, so all the corporate backing from that has waned, and so it's now a community project. But the nice thing is it's very stable, it's easy to maintain, and it just works. And we started using this before OpenStack or anything even existed, and so we have a we have a lot of old stuff that's on it. The bad thing on it, there's really no public API. We've been using it since 2009, and it's really, since it doesn't have a public API, it's really port self-service. On the other hand, OpenStack, it's gotten really stable, but it's a really pain in the rear to maintain, as many people have figured out. It has a really nice API. We've been using it since 2013, but we really haven't been using it for our projects quite yet. And it's really good for self-service. So as I mentioned, our Ganeti cluster is where a lot of our production stuff is. It's mainly command line driven. We do have a GUI. We created a project called Ganeti Web Manager. We've been using it. We use it for projects that have access to the console, but it's not as nice and featureful as like Horizon is on OpenStack. Our production cluster, there's the specs for it. A lot of projects that you interface with, like PHPB, BusyBox, BuildRoot. So Jenkins has, I think their issues site is hosted on a VM on this cluster. QEMU, ironically, has a VM here too. I always love having projects hosted on platforms that we're using of. It's always fun. And then some of the other projects have their own clusters that we manage. So like the Python Software Foundation has one, Civi CRM, OSGeo. And we also have our own internal clusters that we have things separated from the production cluster in case weird things happen. So we use Ganeti mostly for pet VMs, the long-running VMs. Ironically, our controller nodes for OpenStack run as VMs on Ganeti, which is fun and interesting. Hey, it works. A lot of our important traditional services run on Ganeti. And I really see us using Ganeti probably in the long term for a while, even though the project has kind of gotten quiet, but it seems like it's picking up more. But from a sysadmin point of view, it's an awesome tool and it works. From a developer point of view, it's a pain in the ass because you can't really interface it with well. So OpenStack, like I mentioned, we've been using it since 2013. Since then, we've been mostly using it internally with our test kitchen, so we could spin up virtual machines, run tests, and spin them down and do things like that. When we got the new Power 8 systems, the nice thing about those systems is we could actually run KVM on them and manage them in a more sane way. That was actually the first cluster we created on OpenStack, which was an adventure. I actually gave a talk on it a couple years ago on how we got this going. But that's been our main cluster that we've been doing. And then I finally felt confident enough to open up our x86 cluster this past year, so we got some new projects running on it. So all that EMC hardware that we use, the compute nodes, are actually all of the cluster that we have right now. It works really, really well. And so we started trickling in some projects that we've added on there. They use it for a variety of things, whether it's CI, their websites, you name it. Since it's all tied in with all the stuff, it's really nice. I thought I had another slide here, but I think I incorporated it all in here. I'm going to be pushing this more. I need to send an email out to the list, the other hosting, our hosting list, so that projects know about it. But I think this is probably the biggest achievement that I'm really happy about in the past year, is to finally get this out. Because now we can give projects an account. They can spin up VMs, use an API. We have the storage that we need. We have the bandwidth that we need. We have the compute. That'll make things a lot more flexible. Because we really had that limitation with Ganeti. And so OpenStack really helped us get to that point. So if any of the projects out there that don't want to pay for public cloud and they want to have a place to do their builds, we now have an OpenStack cluster where we can do that. Now, another big thing we've done is collaborated with IBM over the past 10 years. In one way or another, we have hosted some kind of an IBM machine for projects that have access to do builds. It really started to pick up when Power 8 was released. And we created this OpenStack cluster. We currently have 5 systems that are running Power 8, and we just got 3 new Power 9 systems as well. We have over 100 projects using these systems. Many, many, many ones. And what's ironic is, when I first started getting this cluster going, there weren't binaries built for the stuff I needed. And once we got those projects access to it, then they could build it on our system. It was a chicken and the egg problem. So it was fun getting that going. A lot of the binaries you use out there that are PPC64 are probably built on this cluster. We also, if you use Travis CI, and Travis CI now has a beta, I think, open for running jobs on PowerPC. I think most of those jobs are now running on this cluster. So they have an account on this cluster, they spin up VMs on this cluster, and they make that work. So that's pretty cool to be able to say that. All of this, the hardware is either donated or goes through their loan program by IBM, and we also get cash donations from them to help support my time, my students' time on onboarding all these projects. We also have a couple of bare metal machines for some other projects. We do a lot of stuff with the GC Compile Fund project. Debian has their own machine. FreeBSD Foundation just got actually had 2 of their own machines to kind of get better support on that platform. So there's that. We've also been diving into GPU systems as well. With TensorFlow and AI and all this coming up, there's been a big need in the open source ecosystem to have access to GPUs. We collaborated with another unit on campus called the Center for Genome Research and Biocomputing, or CGRB for short. They're basically an HPC shop on campus for doing all sorts of stuff. And they've been doing a lot of stuff with GPUs. So they actually manage the GPU hardware that we use on the systems right now, but we share it in rack and we work together. And how they manage it, they use Son of Grid Engine, which is an older technology, that batch scheduling kind of stuff. It works really well for just, hey, I need like a Jenkins job to run and do something. But if you need to be able to do some other stuff, it gets a little bit difficult. We also created a Jenkins portal that ties into that. So what we can do is you can get an account on it, and then your project can set up a Jenkins job. And we have everything going through NVIDIA Docker. So it spins up an SGE job that connects to one of the nodes, and then connects to Docker, runs your test inside of that Docker image, and then finishes it out. Not the best situation, but it works for the most part. Something that I've been trying to work on, I actually been working on it this week a little bit. There's a new OpenStack project called OpenStack Zune. There's always been Magnum, which is their container orchestration service, which I don't need for this. Zune is like making the container act like a VM almost. It looks like a single unit that you can use. And the reason why is having access to the GPUs is you can do it with virtual machines, but PCI pass-through limits how much you can share that resource. You basically allocate a whole GPU unit to that one VM on a big box, and you can't do anything else to that one unit. With Docker, they have a nice driver that allows you to have as many Docker images, and it can access that underlying hardware really easily. So my goal for that is to offer a platform for those projects that want to have an instance where they can log in, do some testing, debugging, what have it. Maybe a little. It's also API driven, so we don't have to go through the SGE system to do all of this. So it's a work in progress. I'm hoping later this summer we'll actually have something. We're going to get some slightly older GPUs cards from CGRB that we're going to do some test driving on, and then if it takes off, IBM will look at funding and getting us some actual real nice systems for that. So that's been a fun little project. And even more IBM stuff. I feel like I'm an IBM person here. We dived into IBM Z a little bit. No, we don't host the hardware. That's a separate university up in New York. They host basically virtual machines. LPARs is what they call it. And we have another Jenkins CI portal. And the part that I love about this is it's mainframe running Docker. And you basically run the same thing. It goes through a Docker image, and you can through Jenkins, and you can do your jobs and all that stuff through it. Oh, go ahead. The question is, how are they running it underneath it? I really don't know a lot about it. I think it's using their normal stuff that they have for managing Linux on Z. What I was about to mention is like the performance on this is really slow, and I think it's because they've oversubscribed this system for a lot of other open source projects. So I think longer term they're going to try and make it a little bit better. But yeah, I think it's using. I know they're using LPAR, so this means they're using the because we used to do a lot of the stuff with LPARs on the power side. So they're probably using an HMC or something. I don't know. I have no idea. I just know I have a VM that's running at Marist. I have 2 of them actually, and it works. So, and we also have some AIX stuff. We don't publicize it that much because it's a volunteer-driven effort within IBM. But we have some boxes that we're hosting. We're not managing them because we don't have experience with AIX. But I know projects like Node.js and other folks that are doing builds and stuff and tests against AIX are doing that. If you're interested with that, talk with me afterwards and I can help you get connected, but they're really limited on what they can do with that right now. And IBM internally has to figure out how they want to manage that resource, but it's interesting. Let's move on to some of the infrastructure enhancements we've had over the past year. Here's a list of the major projects. I'll go through them individually. First one is Chef. We do a lot of Chef, all the time. We have about 130 nodes that we manage right now. Chef had an upgrade on their client from 12 to 13, which is a pretty big one. There's a lot of deprecations that happened in 13. So that was a fun project for our students past summer. I actually have one student I think did most of those migrations. He got sick of it. He did a great job. And so we got everything upgraded to Chef 13 just in time for Chef 14 to get deprecated and 15 to be released next month. But so we're going to be starting the Chef 14 upgrade soon. And we're also been working on updating to the latest community cookbooks. Chef has been moving a lot of their stuff as following kind of the Ansible thought of batteries included. So a lot of what you used to have is use a lot of community cookbooks to manage maybe Docker or whatever is now baked into as a native resource inside of Chef. So that's what changed in 14 quite a bit. We also did some improvements on our testing. We switched to using cookstyle for linting instead of just straight RSpec to kind of match what cookbook should be like. We've also been starting to migrate, moving away from server spec to inspec. That's going to be a project the new students are going to be working on, which is fun. Inspect is awesome. Again, there's a talk later today about it. You should go to it. And we've also made improvements along the way on doing proper peer review, fixing that, better test coverage over the years, or over the past year, and improving our coding standards as all shops kind of go through. We're trying to improve stuff over time, and I think we're finally at a point that things seem to move pretty smoothly on our Chef infrastructure. We still have some hosts running CF Engine. We started this migration back in 2013, and we're still doing it. Things that are left are email relays, Mailman. One of our MySQL clusters is still running on CF Engine, and our Postgres server cluster is running on CF Engine. And then we have miscellaneous project VMs that are doing that, and some other miscellaneous OSL hosts. I think we're actually going to get finished by the end of this year. I'm about to convert one of our miscellaneous hosts over to kind of help with that. So it's fun, but I'm sick and tired of dealing with this stuff. I should say we did make a lot of headway in this past year. We got rid of a lot of old stuff and migrated a bunch of stuff. So that's been really, really good. On the OpenStack side, we've been dealing with a lot of software upgrades. So OpenStack releases go in alphabetical order. The current release one is R, which is Rocky. Stein is coming out relatively soon. And we just upgraded to Octica. I'm currently in the process of getting Pike. I think I got it basically ready to go. And then my plan is to keep marching forward and going through stable releases. We use the upstream OpenStack cookbook ecosystem for all of this, and we contribute back to that. In the past year, we also migrated everything from local storage to Ceph, which was a fun and interesting project that I did. I should probably do a talk about that at some point, because I'm sure other sysadmins, or at least a blog post about it. And that was a nice performance jump we had, and it also allowed for live migration finally, because we didn't really have it set up that way. And of course, it gave us a lot of storage capacity. What I'm wanting to do in the next year is adding support for IPv6 on our OpenStack clusters, which I think shouldn't be that difficult to do. We just need to make sure everything works. And then I also want to add some additional OpenStack services that would help projects if they want to use Kubernetes, for example, or even us if we want to deploy some stuff using Kubernetes. And I also want to improve the DNS integration right now, which is kind of a pain if you want to set up a reverse or forward pointer, but that's something I'd like for us to do. Another big thing that we did in the past year is finally get some the Open Compute hardware going. that we got donated from Facebook. We get the nodes are really nice, at least for our standards, for what the projects need. They have 140 gig RAM. We got 3 terabyte disks donated from Facebook, and they each have 10 gig NICs. That connection came through the GC CompileForm project. Basically, it's a project that gives you access to a bunch of systems if you want to do some testing on your software. And once I got it going, I connected with them, and he had all the connections for all these other projects that needed to have access to it. So within a matter of a month getting this going, projects like WRT now have builder nodes there. Lineage OS has several nodes running there. VLC, we got reproducible builds going on there as well. We have some RISC-V builder nodes. They're actually just they're x86 machines, but they're running QEMU and emulating doing builds on RISC-V. F-Droid, GNOME, Free Desktop, BuildRoot, OpenBSD, just to name a few. So out of the 90, we've gotten 59 deployed. This is actually sitting in a room right next to where my office is, so I get to hear these things running all the time. The fun part about this was the logistics. The rack height. These racks are 7 feet tall. They do not fit in the elevator for where our data center. Our data center is on the 2nd floor in the middle of a building. Awesome place for a data center. So we couldn't get them through the elevator. And even if we could, the network cages that we have set up in the data center are too low, and it would have ran into that. If that wasn't enough problem, the power requirements for these were incompatible with our system-wide UPS system, which didn't support the 277-volt requirement 3-phase that we needed. So we would have to have a special setup for that. So that created a really big issue. And we had this hardware sitting around basically for 3 years until we figured out how we were going to get this going. Around that time, we were moving our offices to a different building. And thankfully, this other building had easier access, and we didn't have to deal with an elevator. We could just go straight through this doorways. So we had this room that we converted into a small little data center-like room. And the racks just barely fit underneath the doors and went through. We were able to get the power in there because we just plugged it in. But then we had a problem with all the network switches were direct power based because these racks normally have UPS racks right next to them, and they're connected to AC and DC power at the same time. So I had to wait a couple of months for them to send us power supply units for those switches so we could actually use that. And then if that wasn't fun, we had to deal with firmware upgrades and understanding how these systems work. There's not a lot of, these are WinFell-based systems, V2, I think. And the funny thing was is when I was Googling around, I found this random thread somewhere on this forum where these people have found these systems on eBay and bought them, and they're trying to figure out how to run Windows and other stuff on it. And they figured out where the firmware and everything was. And so the problem I was having with the firmware was the IPMI was on a shared NIC, and on the operating system, when you boot it up, that NIC shows up. And so whenever the system boots up, when the OS grabs that NIC, you can't see it, the IPMI IP goes away, and then it comes back, and so you can't see it boot properly very well. The newer firmware that I found online, it had the ability so I could turn that off. So that was fun. And then if it didn't, to make matters worse, when I was trying to do the firmware burning, some of them wouldn't boot back up. And thankfully, these systems have removable chips for BIOS, but I needed a burner for that. And so I had to do all that. Anyway, long story short, I finally got these all going, and I got all the firmware updated. You can actually, I think, run core boot on these now. I haven't tried that yet, but I would like to be able to do that. The other part, HVAC limitations. So this room is still using building AC power. We've turned off all heat going into that room. For right now, it's fine. It's working really well, but we can't really scale it up. We only about have half of the systems going. I need $150,000 to get a real HVAC system in that room. If you know somebody that wants to donate money for us to do that would be great. Facebook has actually mentioned sending us some more hardware, and we're going to need that desperately to do that. And then other parts of it, since we're in a separate building, the way OSU does their logistics, we couldn't bring our OSL VLANs over to that building. Our network is actually completely separate from OSU. We're like a separate entity. We are outside of OSU, our network, and so we're running this currently on the OSU network. And so all these systems, I don't have very many IPv4 addresses, so they all have port forwarding for SSH. And we can poke holes for things as needed for all these nodes, but that means I can't use our IPv6 space, which is annoying, but it is what it is. Someday I'll convince somebody to let us use some of the dark fiber between these two buildings so I can do this properly, but so far I haven't been able to do that. Speaking of IPv6, we finally got it deployed in 2016. We now are using it. That's our /48 we got from our ISP. DNS, FTP mirroring, some of our shared websites are using it. We're slowly deploying it more out to some of our internal systems. Not many projects have been using it, but those that have, they're using it. It's working well. We're currently just doing static IP assignment. This is based off of our ISP's recommendation at the time. We're doing dual stack, so every IPv4 subnet gets its own /64. And then we actually have some VLANs or subnets that we use as general VLANs for all these projects, and we've just been assigning /56 reservations to these projects so we can kind of segment it out since there's so many IP addresses. Some other newer things, and I literally just got this going, been updating our metrics and monitoring a little bit. So we now have Prometheus and Grafana going. This website is now working. I'm going to be adding more graphs to it, at least on the public side. All of our CentOS 7 systems now have the node exporter. I've been using the SNMP one. All of our switchers are now being monitored, all of our PDUs, so I know all of our power, and even some of our environmental sensors. What I've been trying to do more is work on more explorators so we have more information. Once I get the Pike upgrade done, we're going to be able to do celiometer and Noki properly so we can get some awesome metrics out of that. And some other metrics, some custom ones. I just got one for our FTP disk mirror usage, so I know per directory how much projects are using. We had a separate older base system that always breaks whenever the new year came around. I don't know why our ID tool was doing that, but whatever. So metrics, we're going to have lots of metrics, and so it'll be fun. We've also been doing a lot with Let's Encrypt in the past year. All of the stuff we do internally, we manage it through Chef. There's a nice cookbook for it. It's really easy for the single host, but when we deal with some of our more complex systems, it's a little bit more of a pain. We have a 2-node HA proxy set up with failover, and getting it to do the validation properly between the two was annoying. And so we have an NFS-based system that shares the certificates between the two, but it doesn't work really well. And we've been getting a lot more requests for projects that have HTTPS on FTP OSL for the domains. And we're not quite ready to do that. We're going to need to refactor how we do that. We do have HTTPS enabled on FTP OSL, but it's only our wildcard DNS. So it's there, but not making everybody happy. So that's definitely where we want to go. Other miscellaneous projects, I finally got Rancher deployed so we can keep track of all of our switch configs in Git, which is awesome. It was a complete black hole before. I did a whole bunch of 10 gig backend network upgrades. All of our Gennady backends are now using 10 gig. Ceph is using that OpenStack. We have a new VPN server that we're using is on 10 gig. I just moved the backup server over to that to kind of help with that. Finally moved away from DWJ DNS to bind, finally, after how many years. Don't have DNSSEC quite yet, but getting there. That's on the project list. We've improved our net booting installations. We're currently using Razor Server from Puppet, but may look at using Foreman or something else eventually. We increased our FTP storage capacity, and thanks to Meltdown Inspector, we did a bunch of firmware upgrades too, and kernel reboots as well. So, finally, goals for the next year: complete that legacy systems migrations, upgrade OpenStack and Ceph to the latest stable. Finally upgrade to Chef 15, which should be released next month, I think. Maybe migrate Gennady to Ceph. I want to finally have an ELK stack. I have all these logs that I like to import into ELK and finally have some metrics out of that. So that's going to be a big project, I think, in next year. Another one is replacing our aging OSL core network. Our core network is actually our uplink is currently on a 6509 switch. That probably will be end of life, I think, in like 2 years. So I'm currently in the process of figuring out how we want to replace all of that and improve our network so that it's going to be ready for the next generation. And then, of course, when CentOS 8, RHEL 8 comes out, which probably will happen sometime soon, we'll start working on that and finally get rid of our CentOS 6 hosts. And literally, in the last week, we just got we've been working with an ARM startup. One of our alumni actually became their developer advocate person, and we pitched the idea. And I basically said, hey, this thing with IBM we're doing, it's working really well. We should do the same thing with ARM. Can you do it? And so they got back to us and it's like, hey, I think we're going to send you 2 racks worth of this gear. So hopefully soon, by the end of the year, we're going to have an OpenStack-based ARM server set up so that projects want to be able to debug, CI/CD, the same stuff we're doing in IBM with ARM. Hopefully we'll have that. So I won't say the name of the company quite yet because we haven't figured out all the details, but that'll be a cool thing to get going. So with that, thank you. Any questions? I went over a lot of stuff. All right. Well, you guys enjoy the rest of your day, and I'll be around if you have any other questions. Thanks for coming out.
okay? Is it actually coming through on the mic at all? Just a little. I'll try to move this closer. It's one of these weird ones that goes over your ear. It's kind of bendy. Now to my face. I'm going to turn off while I do this. Close now. How's that? Is that too close to my mouth now, or is that Peter Piper picked a peck of pickled peppers? All right. Can somebody remind me how long my time slot is, so I can set my timer? It's a full hour? Oh, okay. Wow. Well, I've lots of time for questions then, because I prepped for 40 minutes. I should have looked at the schedule, obviously, but I try to leave a lot of Q&A time. So I don't take questions during my talk because, as I've just pointed out, I leave a lot of Q&A time. So I'd appreciate if you'd hold questions till the end. I'm easily distracted. I do take questions when I'm doing a tutorial because you have to, because you're supposed to be, teaching people. But here I'm just, ranting at you about things I believe. So if you want to stay, you'll have to listen to my rant for the 40 minutes, and then you may Q&A me as much as you like, or just, I don't mind you don't have to start with, I don't have a question, it's really a comment. You can make comments as well if you'd like at the end. So my name is Bradley Kuhn. I am from an organization called the Software Freedom Conservancy. We are a 501c3 charity, which is a detail I will be explaining some in this talk. I will admit early on that I am biased as an employee of a charity, because I believe charities are very good things, and I think they can do good things in the world. That is a radical position in open source, oddly enough. And I'm going to explain a little bit about how the charitable model relates to sustainability, how this whole question of sustainability came up at all in open source and free software. It was probably 4 years ago, maybe 5, when I first heard the word sustainability used to talk about open source and free software. And I hadn't heard that word used in the context of FOSS before. So I looked up in a dictionary. This is from a proprietary dictionary, I should notice. I did look in the free dictionary first, and unfortunately the free WordNet dictionary that's in Debian said that sustainability is the quality of being sustained. And so I didn't think that was particularly illuminating to put on a slide, so I did find the Google definition, the proprietary Google dictionary definition of sustainability, which I read this and I think sustainability is a good thing, and then I found, yay, a freely licensed definition, freely under a CC by SA copyright license. This definition of sustainability is found on Wikipedia, on the Wikipedia page for the phrase sustainability. I read this and I think I'm a fan of sustainability. This is a good thing to do. I wouldn't call myself an environmentalist because I'm as much of an environmentalist as anybody who lives in industrialized society can be. I fly on planes, which makes my carbon footprint gigantic, and I do drink out of plastic bottles, and I do again own a vehicle, although I did not own one for basically 20 years. So there was that. And I only use it occasionally. I don't commute to work. I work from home. So I do what I can. But I wouldn't call myself an environmentalist, but I care about sustainability. So that's good. So I heard, people are talking about FOSS sustainability. This is good, right? So I heard about it and I said, okay, well, so what are people doing? Are people gonna work on stuff for forest management software? Are they gonna help make the environment more sustainable by writing software that solves problems about forest management? Well, no, that's not what these sustainability hardcores were working on. I was like, so maybe they're working on, there's activist organizations like Greenpeace and other people who fight for sustainable environmental things. Are they working on software to help those organizations? No, that's not what they were working on. So what is it that FOSS sustainability was, I inquired. And no one could give me a clear definition, but this was the closest I could get. people were saying, maintainers of FOSS software don't get paid money or don't get paid enough money, and we should find a way to give them money. I said, I'm not against that. I want people to be paid to write FOSS. I think that's really important. I've spent a lot of my career figuring out how to get people paid to write FOSS, and so I want to see that happen. But it was a strange situation because the people that were saying this were thinking in terms of the way the software industry as a whole pays people. There was a lot of discussion about how we should really be running FOSS projects like VC startups operate. We should be looking at putting money into FOSS projects to encourage rapid orders of magnitude growth in projects. I am not really a fan of that model for software. I know that is the standard way that the industry has decided we're going to develop software, but I tend to think of free software projects a lot more like restaurants and a lot less like VC startups. So I'm going to force you all to raise your hand by saying, how many of you like eating in restaurants at least occasionally in the room? I hope everybody probably does. I mean, even I do. I try to be frugal and I eat at home a lot, but I love to go out to a restaurant and get good food well prepared. Most restaurants all over the world, and the United States is no exception, barely stay open most of the time. Only the most expensive shishi restaurants make oodles of money. Your average restaurant, casual restaurant run by somebody who makes some good food, they're happy to just keep running, sometimes for decades, just with enough money to pay all their staff, keep the thing going, be able to make food for people, everybody gets paid. But it's not like they have orders of magnitude growth every year. Very few restaurants become McDonald's. And by the way, I encourage you to watch a movie, The Founder, to see how McDonald's was not really about the people who founded the great food, but kind of a manipulative salesperson who showed up to do things. But even so, even if you consider McDonald's a success, I don't think I want McDonald's software because I don't use Macs and I don't like Apple products, and that's our McDonald's, right? So I want to see the local restaurant that you can go to version of software, and that's one of the things that really drew me to free software. Is so many free software projects operated like a local community restaurant where lots of people made money, lots of people didn't. Some people paid money, obviously, to come and eat, but it was a community place. So when I trace back how suddenly people became obsessed with sustainability of the let's fund projects like we fund VC startups nature, the only place I can find kind of a roots of this happening was post-Heartbleed. So there was a tremendous amount of, I use the word freak out on the slide. I think that's accurate. Companies are saying, oh my gosh, we have this thing in all of our products that's this FOSS stuff. It's licensed under BSD license. All our products depend on it. There was some sort of security thing in it. We don't really understand it, but it screwed everything up everywhere, and oh my gosh, that's really scary. And they freaked out. So historically, when people in big for-profit corporations freaked out about open source, going back into the 90s, they freaked out because, oh my gosh, some sysadmin over the weekend installed Linux on a server and put Samba on it and turned off our Windows NT server. What the hell did they do? They're going to screw up our relationship with Microsoft. But wait a second, our SMB services are much better than they used to be, so I guess we're going to live with it. So that's the way people freaked out about open source in the 90s. It was a counterculture activity. It was people sneaking Linux boxes under their desk. I don't know how many people in the 90s told me they had a secret Linux box under their desk at work that they weren't supposed to have. Right? That was common then, and the freak out was, why is this even in our enterprise at all? That's not how people freak out now. Now they say, well, look at these projects. There's all these projects out there. There's crazy free software hackers working on them. We don't know who these people are. They don't work for us. We can't control them. Maybe we should control them. Maybe we need more control, companies say, over free software projects. Now, I want to be clear. I'm going to be somewhat critical of companies and other types of organizations that companies form for the next few minutes. It's not that I'm against. People constantly accuse. I've been accused of being a communist. I've been accused of hating all commerce. I've been accused of hating capitalism. I'm not against any of those things. I just think that a good culture has a counterbalance to that. I don't think everything should just be unbridled capitalism. I learned that phrase when I was in school. I went to a liberal arts school, and because I wanted to be a Renaissance person, so I was majoring in computer science, but I went to a school with lots of lots of liberal arts courses, and we studied, the Industrial Revolution, and we had a huge problem during the Industrial Revolution that these very, very wealthy people started coal companies and oil companies and meatpacking manufacturers, and there's lots of literature, there's lots of academic research about how bad that was, and we had to make a decision as a culture that unbridled capitalism is not the answer for society. We need to put some constraints, and we need to have watchdogs, and we need to ask questions about, well, why are companies doing things the way they're doing them, and are we happy with that, and do we want something different? And I think that culture has been lost generally in the United States, but particularly in FOSS, it has been lost even more recently. So what happened was, after Heartbleed, there was a tremendous amount of money flowing around. It was already happening for other reasons, but Heartbleed was kind of that watershed moment when companies said, wow, we got to find a way to channel lots of resources into this open source thing to control it, because we can't just hire all the developers, which that's a traditional way that companies try to control a project. They hire its developers. They understand that. Acqui-hire is a thing. They have done that successfully with some open source projects, but most, fortunately, FOSS projects are more resilient to being taken over that way. So what's often happened is funds have been pushed into trade associations, and trade associations have attempted to kind of get control of various different FOSS projects by channeling money into them. And that's the way you get control of things a lot of times in our capitalist society. Now, the interesting thing is you would think that after Heartbleed and after all this, just oodles of money, I'm going to put some slides up that actually show you some numbers in one particular case to show you how much money we're talking about in a few minutes. But this quick infusion of cash did not make things sustainable. And there's still this community of people out there having meetups. There's an annual conference now about open source sustainability that happens every year. People are constantly saying, oh, well, open source isn't sustainable. There's academic researchers. In fact, one person who was funded by a large grant-making foundation published a paper saying that, well, we just have to keep getting corporations more involved because corporations are just so much more accountable than nonprofits are. I was amazed by this. I don't know how she came to that conclusion, but she did, that the accountability to shareholders is stronger than the accountability to the public. I don't get that. But anyway, nevertheless, the problem has not been solved. So I think it clearly begs the question, which I was already asking anyway, is just more corporate money what we need? Is it really a money problem? Because that's what the sustainability conversation is saying. It's like, we need more money channeling into open source. If we just had more money running in, things would be better. I'm not completely convinced it's a money problem. And I've been pretty sure about this since 2013. This is a photo, it could be a series of photos here, from the OpenStack party at the 2013 OSCON in Portland, Oregon. I actually live in Portland, Oregon now, although I didn't at the time, so it was a couple of years before I moved there. And the OpenStack Foundation had rented this giant space it's like an industrial space, basically like a warehouse floor, which they were renting out. It was a closed warehouse. They were renting it out for parties, so they would set it up for a party. And so this was the food. Like, there was these people making some sort of, I forget what this was. They made a thing, like you got a dish, and they let you choose which thing you wanted, and they put it together for you. There's a big line there, and they brought out these cupcakes and cakes, and they had made on every cake and cupcake, they had various logos of the corporate sponsors of OpenStack, and all the cupcakes had a big OpenStack logo, like done with whatever machine they use from the pastry place, and they had these candles were like sparklers or something. It was weird. It was like they were like they were almost like those things you use at 4th of July. That was weird. I was like, is that a fire hazard? And also, if you look in the back here, you see these people kind of lined up. I couldn't find a photo of this, but right back here was this giant open bar where they were making made-to-order artisan mojitos and margaritas that you could order. All you can drink, no drink tickets, and people were going back to the line. I admit that I did get in that line more than once. I ate way too many cupcakes, but I was looking around at this, and I was like, this is not like what I'm used to about the old days of a free software party. There's always been alcohol at these parties. It's admittedly true, but usually it was like a couple of guys hanging around, and maybe 5 or 6 people, like kind of the thing we had last night, where it's like, you know, and there was some games and stuff, but it's not really. There wasn't a giant open bar with free drinks for everybody, with like artists. I mean, the bartenders were very nice. We were chatting with them some last night, but they were not like the people who make artisan cocktails and all that sort of thing, which is what they had here. So this is really over the top. And in fact, they had. So actually, I was going to use a prop, and I didn't bring it. So I actually bought a bottle of that Fiji, the Fiji water. Which is like, the little bottles are like $4 a bottle or something like that. So they had this giant table of Fiji waters for everybody, just like hundreds and hundreds of bottles of Fiji water. Now that's clearly not very sustainable. They shipped a lot of water from Fiji in plastic bottles and gave it to people. So I wouldn't say this was a sustainable FOSS project, given the environmental impact of all this. And so this was their 2013 party. I was thinking about this when I was prepping the talk, and this led me to download this thing called a Form 990. So every nonprofit organization in the United States is required to file one of these every year. I don't have any slides of Conservancy's Form 990, but I encourage you to go download it and read it. It may be very interested to do so after you see some of the examples to compare and contrast with OpenStack's 990 here. So this is the first page. 2016 was the most recent year they had available. Unfortunately, they're actually required to give you the Form 990 if you ask for it, but they haven't made available their 2017 one yet, which should be filed. They're probably not required yet to file the 2018 one. So I wasn't able to they wouldn't give me the 2017 one, but I got this one. And so the front page of the Form 990 has a series of numbers, just sort of summary numbers for the year. So as we see here, the total operating expenses of the OpenStack Foundation in 2016 was almost $30 million. That's a lot of money. They took a $6 million loss there, it looks like. So their loss was 6 times our organization's annual budget. Which was interesting to me, thinking of that. And they actually ended the year in the hole, so their total assets left were a negative $366,000. I guess they took a loan from somewhere or something like that to cover their shortfall there. But they're spending a tremendous amount of money. I mean, you have to if you're going to have artisan mojitos and margaritas and giant bottles, small bottles for lots of people, Fiji water and all that food. I mean, that's expensive stuff. There's no question about that. But there's other expensive stuff they're paying for as well. So this is another, further into the 990, you can look at pages of how the money is spent for independent contractors. So lots of organizations do this. They hire independent contractors to do things. But they're spending a lot of money on independent contractors doing various things. One of these was, I looked up a few of these. One of these was a website development. I think this was a law firm that they paid, so they paid a lot of legal fees. Interestingly enough, they channeled a bunch of money that year to another trade association called the Linux Foundation, so they gave them $245,000 to do community development. I was not aware that, I don't think that community development means software development, because I'm not aware of any Linux Foundation employees or contractors working upstream on OpenStack. So I think this was for other things that is unspecified here. And then there's this is the best page of a 990 you can get. It tells you the highest, so if anybody makes over $100,000 a year, or anybody is a major decision maker at the organization, their salaries must be disclosed. So we see here that their executive director was paid $400,000, various other people making between $200,000 and $300,000 or $400,000 a year. So, and none of these people are developers, actually, as far as I can tell. So it looks like some of them are, infrastructure engineering kind of designed, involved with development. And I asked some OpenStack developers that I know if they knew any of these people. Some of them knew some of their names, but I asked them, so what do they do in the project? It's like, I've never seen them in the project. I don't know. So this is a weird thing. It's weird. So this is where the sustainability money is going, and I don't think it's generating sustainability under any definition of that particular word. Now, I mentioned that OpenStack Foundation, as an example, is a nonprofit, but they're not a charitable nonprofit. So this is a very interesting part of the 990 that is, you'd miss it if you weren't looking closely. But you have to say what type of nonprofit you are. And in the United States, there's lots of different types of nonprofits. And this particular type is called a trade association. A trade association is designed for companies to get together and pursue a common business interest that they have among themselves. Something that the entire industry needs. They're designed to be organizations that do the a rising tide raises all boats sort of thing, to grow interest in the particular thing that they're focused on. The most classic example of a trade association would be something like the Pasadena Chamber of Commerce. I think an organization somewhere that has like a Visit Pasadena booth nearby here. What they do is they get money from all the local businesses and then have little maps and other things that tell you where to find restaurants and what to do in Pasadena. Totally reasonable activity, useful for local businesses, great thing to do. It has become the most popular model for use for nonprofit work in open source generally. There are many, many trade associations in the open source world. There's OpenStack Foundation, there's Linux Foundation, Eclipse Foundation. Those are the first three that I can think of off the top of my head. There's probably a dozen others that are much smaller. And it's really popular. But this phrase here, that common interest among people, but it's not among people, it's among the businesses. So a group of businesses, a group of for-profit companies have an interest, but it's all the interests of the for-profit company, not necessarily the interest of the community or the general public. The difference with a 501c3 charity is the charities are incorporated to do promotion and advocacy and generally help the public good, to do things that help everybody. And I work for a charity, as I said at the beginning, I'm biased. I really like that when I get up in the morning, my job has to be help the public, do things that help everybody. Not a common business interest of one group of companies, but everyone in the world, individuals, companies, hobbyists, unemployed, employed, commercial, non-commercial, all alike, help everyone equally. And I think if you look back historically, most free software organizations were this way. The first organization our community ever founded, the Free Software Foundation, founded in 1985, was founded as a charity. And that was the way you formed organizations in our community for a very long time until companies said, let's put money together and influence this stuff. So when I think about sustainability, I think a lot about like, well, we had some sustainability models. A lot of free software got written in the 90s and 2000s. It didn't get written in the VC style of big graphs with look like hockey sticks, as they say, growth for the projects. They grew slowly but surely, got better. Linux is a great example of this. Even though Linux Foundation now is a trade association, historically Linux was a project that moved very, very slowly with a very small group of people contributing, getting better and better as they could, and really was a counterculture project historically. It is no longer a counterculture project, in my view, and it actually is shunning in many places counterculture influence anymore. And that's somewhat problematic. Being a counterculture person myself, I'm troubled by it. In fact, what I tend to feel is happening is there's kind of a slash and burn attitude towards open source now. What I think is happening is companies are coming in and saying, well, you know, we want to build startups, we want to do this, we want to do that, we want rapid growth, do things. And the thing about slash and burn that I think is really interesting is the reason that people go into rainforest and do this is because it works, at least for the immediate problem, which is, I need some farmland. Okay, let's burn down a bunch of trees. As they burn, they're going to create all these resources that get into the soil. You till it over a little bit. Next season you go, and it's great for planting. Now, it's great for short-term sustainability because you get to grow some food the next season, the very next season. Long-term sustainability, it's really bad. And this is the kind of problem that we've brought in to FOSS that was not here before. We're favoring the what do we do this quarter, how do we make money this quarter, how do we generate revenue this quarter, that thinking it's debatable whether that's appropriate for for-profit companies, but it's not necessarily appropriate for FOSS projects. So I want to give an example of a project. How many people have heard of the PHPMyAdmin project? Yeah, so lots of people have heard of it. Most of the audience raised their hands. And it's a very, very old project. It's not as old as Linux, but it was started in the fall of 1998, which is before anyone took, quote, open source, unquote, all that seriously. It's contemporaneous with the founding of things like the Open Source Initiative and so forth, which is, by the way, also yet another charity in our community. And in 2013, the the PHP Admin project came to Conservancy, which was kind of just getting established. We were actually founded in 2006, but we didn't have any employees until 2010. We were all volunteers up until 2010. So 2013 was when we were really starting to get established well, and they came to us and wanted to become a member project of Conservancy. So what we do at Conservancy is we provide a home to projects. Oh, sorry, I went one slide forward when I shouldn't have. We provide a home to projects that want to raise money. And I actually, when I first heard about sustainability, my attitude was, well, what Conservancy does is try to make our projects sustainable. I mean, if you take the definition on its face, the definition they're using, which is try to make them, not consume resources too fast, consume resources in a adequate way so that they can keep going, but not overdo it. Don't slash and burn. Just try to use the resources you have to slowly make your project better, and that was something PHP was interested in doing. So over the years, we helped them raise money. They launched a sponsorship program on their website. First year, they raised $16,000 from that. The next year, they raised $29,000, and they started to decide to spend some of that money to actually fund software developers. So as you see, in 2014, we gave $3,000 or paid $3,000 to a contractor to work on PHP Admin. They raised even more money the next year, but notice one thing that they did. Their spending is not just spending every last dollar they have. They're spending frugally, even though they have more money available, because they're trying to do it in a sustainable way. So in 2016 was probably the best year of all the years, and even though they raised a tremendous amount of money that year, they only spent about $21,000 on developers. And at that point, they were actually funding 3 different developers part-time with that. Now, these developers were not necessarily in the United States. One of them lives in Brazil. One of them lives in the Czech Republic. I forget where the third one lives. But not areas where they need a tremendous amount of money to live a comfortable life. So they're willing to work for substantially less than wages here in the U.S. But even here in the U.S., in fact, all of them get paid more than my wife does, who works for a domestic violence shelter and has a master's degree to be able to have her job. So when you compare what developers expect they should be paid to do their work with what most people who do work to improve the world get paid, there's a huge discrepancy there. It's not the executive director at my wife's organization, who's managing 40 people to handle a large domestic violence shelter. She makes substantially less than pretty much any software developer I've ever met. Her salary is public. It's in the $60,000-ish range, and she's been almost 40 years working in domestic violence as a social worker and activist. So it's a little bit disturbing that we say, well, we have to make it sustainable. We have to make sure wages are at this high level. I don't want people to starve, as people often accuse me of wanting developers to starve. I want people to get a reasonable wage for reasonable work. I believe in minimum wage laws. I believe that people should be able to have health care and take care of themselves and live a comfortable middle-class life. But the out-of-balance way that we think what software development ought to pay is out of control. And that leads to a lot of this question of we have to make it sustainable the way that Silicon Valley works and the kind of salary Silicon Valley pays. Well, that is not sustainable unto itself, and we shouldn't be porting that back to FOSS. We should think carefully about, well, what do people actually need to live to continue having a comfortable life working on projects they care about? That's the thing I want to build. PHP Admin is doing an amazing job building it. Oh, sorry, I didn't put the last 2 years there. So they continue to do pretty well. They made a lot in 2016, less than theirs, but they're sticking around this. They're raising the amount of development they're paying for every year, but they're not increasing it by 10x, which maybe they could one year. They probably have enough money saved up to do that, but that would be the last year they could do that. And then maybe they have to take a loss on their project, which would be not a loss for Conservancy because we have other projects, but it would be a loss for their fund. So I think what they're doing is really a good thing. It's not a jet-setting project. It's not a famous project that people are like, oh man, like I have to go to a whole conference of just about PHP Admin. They have a developer meetup once a year, but it has, I think, 20 attendees. It's not like the project that everyone's going to have a giant party about. It's also written in a language that people aren't the biggest fans of. PHP is not my favorite language either, but it's a working piece of software. People rely on it, and it needs to be maintained, and people want to see new features added. So that's happening. They're not going to have one of these parties like OpenStack did. I, in fact, would argue that as a charity, we would be our mission if we had a party that extravagant. I wouldn't be opposed to them having a small party by any means, but I think that kind of party is not what a charity ought to be doing. And most importantly, they don't pay giant salaries that some people are getting to work on open source. I think it's great that people make a lot of money working on open source, but I think the expectation that that's what we should strive towards is a problematic assumption. I think this is a good example of doing sustainable FOSS. I feel like that's what we were doing here at Conservancy, and I'm biased, obviously, because that's where I work, but I'm worried about the conversation that we're having about this. I really believe that this way of doing projects that we created a long time ago, which is slow and steady, rather than quick growth, is really what we should be striving for. So I want to end with something. So this is a spoiler alert, I suppose, for a movie that was released in 1945. So, you know, if you haven't seen It's a Wonderful Life, you should probably leave in case you want to be spoiled for it, because I'm going to spoil the end of the movie by the end of this little section of my talk. And I'm a little bit obsessed with this movie. Since Jake is here from LWN, Jake, if everything ever happens to me, I would really appreciate it if you would write me up as the George Bailey of free software. That's like my lifelong goal, to be called the George Bailey of free software. So most of you have probably seen this movie, but the movie has this main character, George Bailey, who spends his entire life in this little town just trying to keep the local mortgage company running so that people can build homes and have nice homes to live in and don't have to pay high rents. This is a scene during where there's a run on the bank and they're trying to get their money out of his little building and loan, which is a savings loan plus a mortgage company that he runs. Of course, the rich guy in the town is this guy, Mr. Potter, who owns almost everything else except the building and loan. And we have people like that in our world. We have effectively, you know, corporate tyrants that are around. I fancy myself somebody that could tell them off, as George Bailey is telling off Mr. Potter here. I have done it on occasion. I've been flamed for it on occasion. And we also have a lot of people like this guy. I think we have a lot more people like Sam Wainwright. So the Sam Wainwright character in the film, he's George Bailey's one of his childhood friends from the town. He ends up being very successful, because his father had a lot of money and he was able to start businesses and made a lot more money himself. And he's kind of a jerk. He teases George a lot and that sort of thing. But they're ostensibly friends. And when the crisis happens at the end of the film, when there's money missing and because of a bookkeeping screw up, basically, they go to the town and ask for money. Now, the most interesting thing about this scene, this is the final scene of the movie where everybody collects money to make sure that the building and loan will stay open. The end of the scene, they announced that Sam Wainwright has offered to advance the building and loan $10,000. Now, the interesting thing is right before that line is said, they figure out that they have enough money already just from the townspeople. So the Sam Wainwright money is basically just a backup at that point. And the other thing is the line is that he advanced the money, so it's actually a loan. There's strings attached. It's not really like he's just giving the money to keep the building and loan running. And we have a lot of people like that. I think that Sam Wainwright is well-meaning, and I think we have a lot of people pushing money into open source who are really well-meaning and are willing to push a lot of money into open source, but there's strings attached. And this is why I work for charity, because I want to raise money from the public who like the work that projects are doing. Won't be very much, but it's enough, as I've shown by example with the PHP Map project, to fund that project, and I think we could do more of that with other projects. I think that's what software freedom was ultimately about. I actually want a very diverse world of how free software gets developed, because if all of it is developed by large for-profit companies, we'll have a tendency to only be working on problems that solve the computing issues of those companies. When you look, and I encourage you, if you have some time, to watch a talk my colleague Karen Sandler and I gave at FOSDEM this year as a keynote at the large free software conference in Belgium, Brussels each year. We were fortunate enough to be the opening keynoters, and we talked at great length, which I'm not going to go into too much detail here, about how difficult it is to actually get all your computing done with only free software these days. And I believe the reason that is while we're writing more and more open source and free software every single day, and there's probably more code licensed under a FOSS license every day than there ever has been in the history of software. Yet, it becomes a little bit harder every day to do your daily life activity in industrialized society using only free software, which to me is a paradox. Because if we're getting more code, shouldn't it become easier to avoid proprietary software? Why is it becoming harder? It's becoming harder because most of the FOSS being written is focused on very specific areas, like OpenStack and Kubernetes, which as far as I can tell solve roughly the same problem, and both have lots of money going into them. Not opposed to competing projects trying different approaches, but companies are dumping probably millions of dollars in those two projects combined. We saw at least $29 million to OpenStack alone in 2016. But the projects for things like free software apps for mobile devices, there are very, very few. There are some. People have written free software apps for Android, but they're not that many, and they're not being well funded. And we're not helping people fund those kinds of projects. I hope that through our organization we can do some of that, but we're small, and charities generally are small and scrappy. But I think as a free software culture, we have to start questioning, why is all the resource going to very specific technologies and not others? And how do we change the system of how we're organizing our projects such that we're prioritizing those things that the general public needs, not necessarily the big businesses need? So I realize my analogy with this, old movie is not perfect, but it's a morality tale as well as a movie. And I like the movie so much more than I did when I was a kid now, because I often think of each FOSS project as kind of a little small town where people are trying to do things. Small towns have problems. I mean, there's not a single. I mean, the only non-white person is a servant in It's a Wonderful Life. So there were problems that we face in society, and there are problems we face in projects as well. Small towns have their issues, but if it's a choice between a small town and a few big corporations, I'm going to pick the small town as the place to live in rather than a corporate campus. I think that what we need most is more George Baileys. While as I mentioned, I'd like to be called the George Bailey of free software, I'd like to see a lot of George Baileys of free software and fewer Sam Wainwrights, fewer Mr. Potters in our community, because I think we have a lot of those. So anyway, I realize the analogy is not great, but I think it kind of helps to think of a morality tale of our culture and consider how that interacts with what we're actually doing here in FOSS. So I've left a good 20 minutes here for questions. So there's a mic. I think they want questions asked on the mic. Can I get a volunteer who will take the mic around to people who want to ask questions? No one's jumping to volunteer. Oh, you will? Thank you, man. So does anyone have questions or comments, thoughts?
Thanks. I just wanted to clarify, all of these examples that you've been giving, are their main source of income is donations? None of them have other means of making money through their open source to sustain themselves?
I assume OpenStack, so I give a lot of different examples of different funding models. I assume OpenStack is getting most of their money from big companies because they're a trade association and therefore funded for the common business interest of all the members of the OpenStack Foundation, all of which are for-profit companies. PHP Admin, which was my main example on the charitable side, most of their money comes from actually a sponsorship program on their website. A little sponsorship page where people pay to put their logos up, which is totally permissible for a charitable project as much as it's available to others who aren't charities. And they also do get individual donations as well. We have a lot of projects in Conservancy that are funded primarily by individual donations. Our Godot project is one example. It's a gaming engine that is funded mostly by individual donations. They have a Patreon page as well as having regular PayPal donations, and they're actually funding 4 developers right now full-time work on Godot. So that's an interesting case because it's a gaming engine, which in the gaming industry, it's very hard to get gaming stuff started, and they're able to do that because there is interest from the public in having a free software, freely licensed game engine to build on top of. So I feel like there are a lot of models out there to do things in a charitable way. I wouldn't say Godot is moving as quickly as, say, a proprietary game engine would, and who's selling it for huge amounts of money to other companies who make games. But they're moving right along, and they're making improvements, and they're funding developers. I mean, from my point of view, if we're funding a couple of developers on a project, most projects, that's all they need. It's not like that you need. I mean, I read the Mythical Man Month, which should be the Mythical Man person, when I was in college, right? And a computer science student, like when you add more people to a project, it doesn't necessarily make it move faster. So finding the right number of people, which for most projects is few, there's actually models out there, like donations, like crowdfunding, that exist and have existed for a long time. They're not new. Crowdfunding seems like it was new in the 2000s, but crowdfunding was, when I first started crowdfunding, I was like, that's what we've always called fundraising in charities. Like, you ask the public to give you money, and now there's easier ways to do that, which is great, and which means we can do more of it. Yeah, go ahead.
It seems to me that the problem, or how the FOSS projects are funded by large corporations, basically, is less of a problem than how those corporations then turn around and use the software, that free software, to create proprietary solutions.
I think I agree with you, that's a problem too. I'm not sure which the bigger problem is. I think they're both problems. Certainly it's the case that there are lots of for-profit company employees being given time to work on open source projects. So in that case, they're not. There's at least they're not making proprietary software. Now, most big companies probably have a lot more proprietary developers than they do open source developers, Red Hat maybe being the only exception, at least for the moment, until IBM owns them, which probably is the other answer with IBM. But I think that we have to be looking at both problems at the same time. I'm particularly worried about the problem of co-option. I think what's happened in FOSS is companies have taken it on because it was advantageous to get software written well, and they've applied FOSS methodologies to how they do not just their open source development, which is all focused on stuff they're interested in, but they're even applying FOSS methodologies to how they do proprietary software. There's this whole initiative in big companies that's been championed at many times at many conferences, not like SCaLE, which is a community conference, but the big corporate conferences, called InnerSource. The idea behind InnerSource is just taking FOSS methodologies and applying them internally to proprietary teams. So that's like the pinnacle of co-option, of saying, oh, we, as part of our work to make software freedom in the world, we came up with a bunch of methodologies of how to develop software decentralized around the internet, and companies have come along and said, what a great methodology. I'm going to apply that to how I do my proprietary software, and I'll write proprietary software even better. So I think you're totally right that that's also a problem, but I think both problems are happening there. And I think this is the one people realize less. I think most people in our community can see, oh, you actually, IBM's got a huge booth over there. You can walk up to the IBM booth. I know all the people there. You can tell them I sent you and say, hey, you all mostly develop proprietary software, don't you? You only do a little bit of open source. You're absolutely right about that, and we should criticize it for that. But I think most people are aware of that one, and a lot fewer people are aware of this issue. So that's why I proposed the talk to actually talk about it. And I want to thank SCaLE, by the way, for accepting this talk. I've been proposing this talk at conferences for about 2 years. I mean, Linux Foundation always rejects this talk. No surprise there. But yeah, SCaLE was the first conference to accept this talk after like 2 years of presenting it. So I'm really thankful to SCaLE organizers for giving me a forum to talk about this. Yeah, go ahead.
Yeah, and thanks so much for doing the talk. So I'm involved with a project, excuse me, that's organized legally as a limited liability corporation in California, Delaware, somewhere in the U.S. And we do not have any U.S. nonprofit status yet. And I've advocated that we should be looking at setting up a 501c3 educational entity and or a 501c4 membership entity. A lot of nonprofits have both types of entities, and that the LLC could actually be a service provider to one or both entities. I'm a partner in the project, meaning I contribute $100 each month. Many of the partners are folks who are running businesses to help folks use the project software. So I guess my question is, I think we've checked out some of the resources available on the Conservancy. Would you recommend for projects who may not yet have nonprofit status of whatever flavor whether in the U.S. and or other statuses in the EU and all over the world. Is it worth looking at? And is it worth? It's not free to do. It may not be a lot to do, but there is some steps, I know in the U.S. to do to be set up. And then once, if you set up as a C3 or C4, then there's some rules you must follow. And one of the rules I think is that it can't, for a C3, it can't be purely for the benefit of the partners of the org who run businesses. It has to be an educational component, which I believe our project clearly meets, because we do annual conferences, we have a public website, we do a lot of, and the clients are nonprofits themselves. And it's called civicrm.org, it's open source CRM, and it's great stuff, so thanks.
Yeah, I mean, a lot of people do use, civicrm is probably one of the most widely used nonprofit systems. I think civicrm has been through a lot of challenges in its history. Because I've talked to many civicrm people over the years about what to do about their status and so forth, and so I think that's it's interesting. But the thing is, you're still chugging along. That's the most important thing, and I think that's very valuable that's happening. Certainly, I would like to see. You mentioned like C4s and all this other stuff. I would really love to see more experimentation with other models. I think the C4 model. So for those in the audience that don't know all this IRS tax code like he and I obviously do, C4 status is more of a membership-based organization. Like a lot of times unions are C4s, those kinds of things. That's a typical kind of structure there. I actually would love to see people, what's that? Oh, unions are C5s, right. C4s are, well, ACLU is a C4 as an example, I think. Yeah. Yeah, so I'll talk about that briefly. So you mentioned the co-op model. Yeah, and there's some people experimenting with doing co-ops to develop free software. Some states have a public benefit for-profit corporation filing that you can do in various different states in the United States. I would really like to see more experimentation with this model. I didn't mention as much in the talk as I would have liked to. I actually think when I got involved with FOSS, what I was thinking FOSS would be lots and lots and lots of small businesses. I thought I was going to eventually form like a small business that employed 5 or 6 people. That was kind of what I thought I would do in my 20s. And I actually wanted that model. I wanted to see lots of small consulting companies working on FOSS, because around in the 90s and early 2000s, that was what most people were doing with FOSS. They were forming small consultancies, and there's still a lot of those around that exist. If you poke around, you'll find dozens of them that are around in the community. A lot of them contract with some of the larger companies now, but there is a good, healthy component of that, and I would like to see more of that. I don't think open source development, if you look at, for example, the numbers that LWN, where Jake writes for, publish numbers about who contributes to Linux kernel and how much code comes from big companies, and more, all the code in Linux is coming from very large companies. And I would actually like to see that flipped over. I'd like to see just lists, like the plurality of contributors, to be lots of people at lots of different small businesses all over the place, to counterbalance this kind of control issue. So I don't think it just needs to be nonprofits. It doesn't necessarily need to be any 501 status. Just smaller entities getting involved in FOSS is a big deal and important. And I think there's a lot of opportunity there too for small businesses as well. If you don't want orders of magnitude growth. Like if you want to get VC, there's probably not a lot of opportunities for VC-funded FOSS. I think there's tons of opportunity for, I want to form a business that employs me for the first 2 years and employs 2 people for the next 4 years and employs 5 people for the 10 years after that. I think it's totally doable. Yeah. I don't know where the mic is. Yep, go ahead.
What are the actual conduits through which most of the donations that flow to the member organizations take form of? Is it just individual people donating small amounts of money through PayPal? Is it something more mature than that?
Are you asking specifically about Conservancy?
Yeah, specific to Conservancy.
Specifically about Conservancy. Every project is different. I mentioned how Godot, when I was answering the question over here, has a Patreon page where most of the revenue comes from. Inkscape is the project that gets almost all of its donations, which are now very substantial. They actually had a meeting this week to talk about how to spend more of their money. Most of their money is coming from $5 and $10 donations. Like basically every day we get a couple $5 to $20 donations from people who have downloaded Inkscape and like to use use it. Other projects run a sponsorship program. Other projects run a conference. There's 3 or 4 of our projects that generate huge amounts of revenue by running an annual conference and charging people to come to it. And then they have surplus left over from the conference. And they actually have, those are some of our largest bank balances that we have for those projects, and they can't even figure out how to spend all that money. Like one of our projects, I don't want to say which one, has more than $500,000 in the bank that they're like, how do we spend this? Like, we don't need this money. Like, the project's going great, and we don't actually even need the money we've raised through running our conference every year. So there's lots of situations where there's funding models out there for projects that can happen in a charitable way, but they don't generate $29 million. I mean, if you put all our projects together, I think we have something like $3 million of all project balances together. If you look at our 990, and our annual budget for all our projects together is something like $1.2 million. Right? So, and we have 50 projects in Conservancy, 50 different open source and free software projects and initiatives. So I think the orders of magnitude people are thinking on are way too big. I think a lot can be done with smaller amounts of money when you make good plans and spend it wisely.
Got it. Thank you.
Oh, my laptop's not, I thought I plugged it in. Thank you for telling me. It's plugged into this outlet must not be live. You all have seen my URLs already, so if it goes to sleep, it goes to sleep. Go ahead, take the next question while I plug this in various places.
Have you ever encountered any organizations that were for-profit corporations where the funding for the open source would come from the profits of the corporation, but the corporation was completely owned 100% with no passive investments by its employees?
I think the best example of that, and I'm going to let my laptop just die because I can't find a place to plug it in. I think the best example of what you're asking about is a company called Igalia in Spain. I believe they are completely employee-owned. I believe they took absolutely no VC. I think they employ somewhere less than 100 people, but around that number, as I recall. Maybe they're bigger now. I haven't looked into them in a couple of years. But I believe they're a completely employee-owned company that does just open source and free software consulting work. So that's the best example I have of that. I think there's some sort of Spanish type of status that you can file that they did in Spain. But like, like we were talking about over here with the public benefit corporation stuff, that's a similar status exists in many states in the U.S. that people, only a few people are really pursuing that about FOSS right now. I'd love to see more of it.
So, I mean, how you compare the nonprofit organization here in U.S. and rest of the world, especially in Europe?
Yeah, so the European nonprofit structures, there's some interesting ones. There's 1905s in France that are very interesting, and there's a lot of them. One of the problems with the 1905 is that 1905s, you can actually donate to them, and the money is not a tax deduction, it's a tax credit in France, which means basically you can pay your taxes to a nonprofit. And that also means that the legislation in France about money leaving the country is incredibly strict. So there's a lot of really interesting organizations doing FOSS work in France. April is one of them. It's a well-funded organization doing advocacy about free software. But they do primarily only work in France because the money really can't leave France due to the legislation there. And I know I have that's worse. I know I have a tremendous U.S. bias about this because I'm here, but I have really spent a lot of time talking with my colleagues all over the world about the nonprofit structures in other places, and the charitable status in the U.S. It seems to be relatively unique. There's not a lot of other statuses where you actually are legally bound as employees and board of directors to act in the public good. There are some analogies, like the French was one example. There are the various analogies. There's the Stiflings in Germany, and actually that's how the LibreOffice Foundation, the Open Document Foundation it's called, set up. But there's actually a talk online you can hear from one of them who helped found it, who was sort of like saying, well, it hasn't worked out like we hoped it would. And then there's the EVs in Germany, but they're membership-based. They're more like 501c4s and 501c5s here in the U.S. So it's that C3 status is kind of neat. Also, I think actually what I've seen is the trade association type, which is what OpenStack Foundation, Linux Foundation are. That's actually relatively unique in the U.S. But it's a very U.S. kind of thing to think. A bunch of businesses can get together and not pay taxes on money they want to go after the common business interest. I suspect it's probably a good thing there's not analogies to that around the world. But yeah, I know I have a pretty big U.S. bias because I was born here and helped form an organization here, et cetera. So, yeah, is there something to ask?
I mean, there are similar organizations in U.S. like a Red Cross and other non-profit organizations.
Mm-hmm.
So, I mean, how they're working? Can we borrow something from their model? Is fit here in our environment and open source?
Yeah, I mean, there's lots of. I mean, yes, the Red Cross in the U.S. is a 501c3 charity in the U.S., just like Conservancy is, and Free Software Foundation, OSI, so forth, are here in the U.S. I think that one of the interesting things not necessarily interesting, but one of the jokes I like to make is, we don't have sad puppies and kitties. Like, I own dogs and I care a lot about animal rights and so forth. But, when you see the ad with Sarah McLachlan playing and the dog, in trouble, yeah, it pulls at heartstrings and people want to give. We don't have that kind of thing, in part because I think a lot, and this might be a pretty radical statement, but I think we have so much privilege in our community. Everybody is very privileged. This whole sustainability conversation is basically a privilege conversation. It's like, how can I get paid $100,000 a year to work on my project? Well, maybe you can't. Maybe you're going to make $40,000 or $50,000 a year working on your project if you don't want to just do what a company tells you. And lots of people in the United States live on $40,000 or $50,000 a year. And that's not necessarily a bad thing. And so this idea that we're going to create organizations that can fund people as much as they would make working for a company, I just think it's wrong-headed, right? And most people who work for like the ASPCA or one of these other charities don't get paid that much. So I think one of the things we can really borrow from other charities is there's a lot of discussion in the foundational world generally about, salaries, executive salaries and stuff. In fact, you mentioned American Red Cross. American Red Cross has been criticized because they pay their executives too much. And there's a lot of discussion in the foundation world, like maybe we shouldn't be paying $1 million salaries to people who run charities, no matter how big it is. And so I'm also a fan of that as well. That I'm glad that the IRS has paid attention to that and raised that issue, because I think we have to be realistic about what is sustainable, right? Because slash and burn isn't sustainable. We have to develop a community that's going to last for decades that's improving a project. And if we just say, let's dump resources in it till it all burns up and makes a bunch of money for a lot of people, but then isn't a project anymore later, I don't think that's the way to go.
So let's assume for the moment that Mr. Potter is never going to become George Bailey. How do we take the well-meaning Sam Wainwrights and convince him to be George instead?
So thank you for asking a question based on my goofy analogy. That is much appreciated. I don't know. So I think the interesting thing is that yeah, so there's that interesting thing. So you asked about the analogy. I'm going to keep with the analogy. So there's that interesting scene. So this is like hardcore It's a Wonderful Life fan discussion, so hold on. If you're bored by that, just bear with us. So there's that scene when when he first goes to see Mary at her house, and then Sam Wainwright calls, and then it's a scene people miss unless you watch the movie like 3 times a year like I do. He's on the phone and he's like, well, we're going to do this big thing, you should invest in us. And George, instead of saying like, how do I get my money into plastics, right? And how do I scrounge up some money so I can invest in Sam's big company and make myself some money, his first thought is, well, you could build a factory right here in Bedford Falls. You don't need to go to Rochester. You can build it right here. Yes, I can literally quote lines from the movie. But I mean, that's the kind of thing that Sam Wainwright needed here, because he does build a factory in Bedford Falls. He does improve the economy in Bedford Falls. And so I think we need to be telling the Sam Wainwright, speaking truth to power, and saying, which is what I do when I talk to corporate people, I say, no, this is not what you should be doing. What you're doing is not helping. Do this other thing. It would be better. It would help people. It would help free software more. And so I don't think we're going to change them into George Baileys, but we have to be the George Baileys willing to say, I don't care about like making money with you. I don't want your money. I want to tell you what I think you should do that would help people more with the money you have.
How is your organization different from the Free Software Foundation?
So I should disclose, I worked for many years for the FSF, so I'm a former FSF employee. I'm also still on the board of directors of the FSF. The FSF has focused more in recent years on advocacy and education, so they're more about educating about what free software is, explaining it, helping people understand what it is, which is incredibly important work, and I'm glad they're doing it. And over the years, the FSF has done less of free software project stewardship. They still are the stewards for the GNU project, but they're kind of just confined to doing it for the GNU project, generally speaking. One of the reasons Conservancy was founded was, in fact, because there were projects that GNU wasn't interested in that needed a home, which is actually one of the original inspirations in us founding Conservancy, because the FSF was like, well, these aren't projects we really want to help because they're out of our scope. And so we're actually, in some ways, we're kind of inspired by some of the early FSF work. I'm incredibly inspired by Stallman's early essays about how to fund free software, where he talked about, well, maybe we should just people should fund free software with donations, right? He said that in 1986, like, oh, maybe software could be funded with donations. And it was like, it's still considered such a radical, like, why should we fund software development with donations? Well, like PHP Lab, I see a lot of good software being written from donations. So at least some projects should probably be funded that way. So we're kind of inspired by some of the early things the FSF did, and the FSF had to, I think, specialize more, because all of these charities are small. I mean, the FSF looks big from our point of view because we have 4 employees and they have 12, but it's like, when you compare it to the Red Cross, right? I mean, everybody's got bigger organizations. You compare it to something like the EFF, which has hundreds of employees now, you know, we're all small here in the open source and free software space. You got another one over here?
I think it should probably be our last one, because it's bottom of the hour.
Well, thank you, Ben, for running the mic.
I'm like a lot of people. I've got ideas, and the next step is trying to move forward on them. I would love to move into a space where I take my ideas and could run with them as something like nonprofit or open source, but it's hard for me to justify, working full time on such a project and learning all of the ropes when I'm unemployed. So I'm kind of curious, is there sort of like a beginning tutorial on how to enter into that space of leading such causes from the ground up?
Well, I mean, none of us who are leaders started as leaders. We started as, as just mundane contributors. I generally think that we need to find more ways to fund people who want to get involved with FOSS development, to actually get involved. There is this sense, and this is really problematic, that you have to volunteer for a project for a while before you can work there. Restaurants get in trouble, to use a negative restaurant analogy now that I've used some positive ones. Restaurants get in trouble all the time where they used to do a lot of restaurants still do this, where somebody will show up and they want to be on the wait staff, and they say, oh, we'll work a shift and we'll see if you're any good, and then we'll hire you after if you're any good. Like, that's really inappropriate. Like, people should get paid to work, and if they get fired, they get fired. Okay, I've fired people in my life. You have to do that sometimes, but you should get paid for work you do. So I think there should be more mechanisms for ability for people to get involved. At Conservancy, we run a program called Outreach. That's specifically, you may or may not qualify, it's specifically for underrepresented groups who haven't historically been involved in open source and free software. So you fill out an application which you give an essay of sort of the challenges you faced in your life to try and get involved with technology. So if you have such an essay in mind, you might be able to apply. But we focused on that area. But I think generally speaking, that's a place where we were asking here about, like, what do you tell companies? I think we should tell companies you should have more of those kind of programs. There's I know you're probably not a student, but Google Summer, are you? Oh, so do Google Summer of Code. So you should absolutely do Google Summer of Code. Yeah, because that's only for students, and if you are a student, you qualify, and that's an opportunity to be funded to work on an open source project and start contributing to something. And you won't just learn that particular project; you'll learn the general methodology of contributing. And I think we need to be teaching people more about that. And those programs are great because they include a mentor that actually helps you get acclimated. All right, well, I'm out of time, so I'm going to hang around outside for a while. I have to go to the airport pretty soon, but if folks want to chat more out in the hallway here, I'll meet you out there in a few minutes.
Test. All right. We'll be starting in a couple of minutes. Welcome. So the original idea, the original proposal was to do this as a tutorial. And the proposal was accepted, and then later there was some back and forth like, oh, actually, we thought this would be a presentation. So this was originally 90 minutes worth of content. So I'll have 45 minutes to go through it. I may not get through it all. I'm not going to rush. But there's my email, my Twitter handle. Feel free to reach out. I'll send you the full tutorial. And if you have any questions on the tutorial, feel free to get in touch. So I'll just check one more time. Is the font size okay for everybody? Or should I make it larger? A little larger? Okay, thank you. Thank you. Let's see. Let's see, properties, font. I'll just go to the next one up. How's that? All right, thank you. All right, so I encourage you to follow along. If you have a laptop with VI on it, you can try some of these out. On my website, I put a copy of Alice in Wonderland, just to have some ready-made text to work with, courtesy of Project Gutenberg. Oh, I see that. The bottom line is cut off. Okay, hold on a second. Thanks for that. How's that? Put it in full screen. Thank you. Attention to detail. Very good. All right. So if you want, you can download this file with curl or wget. Fair enough. With tool of your choice. So I'll just go ahead and start with that. Alice.txt. Well, the formatting is a little bit off because of the large font size, but that's not going to bother us, is it? All right, good, thank you. All right, so it's 3:01. Actually, we'll go ahead and start. Thanks for your interest in this session. My name is Alexei Tsilolikin. I'm a system administrator. My background is as an operations engineer, systems administrator, and I always knew just enough VI to get by. I was always too busy to like really learn it, so I knew enough how to open a file, make some basic operations, but I never took the time to fully learn it. And that's VI. I'm talking VI 20 years ago. Now we have Vim, which is VI improved, and it's got so many more features. So finally, a few years back, I was teaching a class on configuration management, and I was watching this team of sysadmins struggle with their editor. Right? They were using the mouse, copy and paste text. They were using the arrow keys to move around. They were doing some things that seemed to me a little bit strange because I knew how to do it in VI and a lot faster. So that inspired me to put together a course on VI. And what I did was I went to the source text, Introduction to Display Editing with VI by Bill Joy, the author of VI. And this is where he presents VI to the world for the first time. And he says, well, these are the core features, and these are the advanced features. So in my class, I present all the same features in the same order as he did. So I hope to get through as much of the core features as I can. And as I mentioned earlier, feel free to email me. I'll send you the full tutorial and links for further study. Okay. My notes. Okay, good. So I'll start just by talking briefly about Vim, right? That's VI improved. And VI itself, what does VI stand for? Visual, that's right. And why was it called a visual editor? Yeah, exactly. It was improvement over the line editor. So before that, you would edit like a line at a time. You would see a line at a time. You would see it on a 80 characters, and you have 24 rows or 12 rows, depending on the model. And so VI was an editor to take advantage of the capabilities where you can address. It's an addressable screen, so you can move the cursor anywhere. So you can see a screen at a time. A big improvement over editing your file, your program, whatever, your config file, a line at a time. All right, so that's VI. Just a quick survey. Can I show a hand? I see a show of hands. How many of you are brand new to VI, like have never used it before? Okay, good. So I see 2 hands. Okay, good. That's fine. I'm not assuming that you know anything. And how many of you have been using VI for decades? Okay, fine. But I don't know it. Okay, right. Yeah, I understand. Yeah, I had somebody come out of my class saying, I've been using it for 18 years, I learned something new. So I hope that even in this abbreviated version, you will walk away with something new. All right, that was about half the room that raised their hands. So obviously, everybody in between as well. Don't want you to feel left out. All right, so I'll start by saying, when you open up, when you use VI, which you can do on Linux by typing VI or Vim, and then the file name, that's how you invoke it. All right, this is what you see. So what happens here? VI reads the file into memory. So you're not actually editing the file on disk, you're editing a copy of the file in a buffer in memory. And it displays the contents of the file from the top of the file to as much as will fit on the screen. All right, at the very bottom is a status line. So you see the name of the file you're editing. You see that it consists of 3,740 lines. Then what's that next field, 16,000 something C? Characters, right, that's the character count. And then what's next, 1, 1. Cursor position, so that's line 1 column 1. So I'm just moving it down 1. How about this one? That's an interesting one, 0-1. Any ideas what that is? That's right. There's nothing in this line, so it's not the first character. It's the zeros character and also the last character, the first and last. There's nothing there. Okay, fine. Moving around the buffer. Okay, so let's do this. HJKL. So when these I'll put the J here and the K here as a sort of diamond shape. So use J to move up, use K to move down, L to move right, H to move left. When these terminals started appearing, they all had different special control codes for things like left, right, and arrow keys and moving the cursor around. So rather than trying to keep track of them all, the author of VI said, fine, we'll just use the regular keys. And another advantage of that is those keys are on the home row. So that makes it very fast, especially if you can touch type. So if you're currently using, and I'm happy to take questions if there are any questions. Yes, please. If you press J, it goes down. Yeah, I got it wrong, sorry. I've been using it so long that it's just muscle memory at this point. Thank you for the correction. Thank you for the correction. Okay, so that's correct. K goes up, J goes down, L goes right, H goes left. Yep. Purely muscle memory. Okay, so then you have the advantage of adapting. I went through this myself after I switched from QWERTY to Dvorak. I had to, my muscle memory was impacted, so yeah. In any case, it's still faster than moving your hand over to the arrow keys. So, all right, so now I'm going to talk about special characters. Escape. So escape, while you're inserting text, takes you out of that and takes you back to command mode. So VI has two main modes. So when you start it, you're in command mode. So anything you type is considered as a command. So for example, this L and K, those are movement commands. If you want to enter some text, if you want to insert some text, you type I to go into insert mode. So for example, I go I, and I can see I'm in insert mode. There's an indicator there on the status line, little guide. So I can say, hello SCaLE. I'm done typing. I'm going to press escape. It takes me out of insert mode. I'm now in command mode. There's no indication that that's the command mode. That's just the default. Okay. Another special character is the one marked enter on modern keyboards. In the older days, it said carriage return, right? And on a typewriter, it would actually return the carriage and move it a little bit so you get the next line. So you can press enter to move down a line, just as when you turn the carriage, you scroll down on the paper. Or if you're entering a command that starts with colon, and you press colon, it's a special command. You get the cursor on the bottom line. Now you can type a command, for example, write the file to disk, write the buffer to disk. You press enter, tells VI that you're done entering the command. They can go ahead and take it. Another special command is Control C. Control C is interrupt. So if there's an action that's taking too long, you can interrupt it with Control C. I'll give an example. So I'm entering a command. I'm going to run an external command. That's the bang. So I'll just run the slip utility for 100 seconds. Okay, so there it goes. It's running. I'm going to interrupt it with Control C. So there it is. Command terminated. Press enter. Okay, I'm back to my text. So if you're searching a large file, or if you're doing some operation that's taking too long, you want to abort, you can use Control-C to abort. All right. So let's say you opened your file, you made some changes, you want to save and exit. The way to do that is uppercase Z, Shift Z, Z. Very fast. Now I know some of you must be thinking, well, what about :WQ, write and quit? That works too, but that's 4 keystrokes compared to Shift Z, Z, which is 2. When VI was developed and first used, it was in the 70s, and the telecommunication link was a 300 baud line, right? So that's 300 bits per second. So that's about, let's see, 80 characters in a line, right? So 4 lines, a little bit less than 4 lines of text in 1 second. So that means that you can see, I don't know how many of you have used a 300 baud line. I had that experience in my formative youth, connecting to bulletin board systems, BBSs and so on, but you can actually see the lines appearing on your screen, right? So when you type something in VI, the command is sent, right, to the remote computer, and any answer or acknowledgement is sent back to you, right? So it's a round trip. It's a round trip. So VI was designed from the ground up to be terse. The command language is terse. So that makes it very powerful, because with just a few keystrokes, you can transform text in a powerful way. You can make a big change with just a few keystrokes. So if you want to quit, Shift Z, save and exit. There it is, it's done. I go back into it, and there's my changes. If you want to abort, if you don't want to save your changes, for example, if I put a mistake here, I want to abort, :Q is quit, right? But if you try to do that, you get a little warning. Error 37, no write since last change. It gives you a hint. Add bang to override. So I'll go ahead and do that. Quit, bang. So abort. Or I can type :E to reload the file from disk, discarding the changes in the buffer. That's a very handy one. You open up a config file, you think you might have made a mistake. You don't have to quit and then go back into it. You can just dump the buffer and reread the file from disk. There it is. Okay, now I'm going to talk about scrolling and paging. So I'll just define the term. Scrolling is moving through the text in the file so you can see it, right? But moving through it less than a screenful at a time. If you think of a scroll, right? A scroll, you unwind it on one end and wind it on the other. So you move through it gradually. So Control-D scrolls down half a screenful at a time. So notice on the bottom here I have the title and the author. Control-D, scroll down half a screenful at a time. So you can follow along as you're reading. If you want, you can do 1 line at a time. Control-E. There's a mnemonic to expose the next line. This is Control-E. Control-Y moves you in the opposite direction. By the way, most VI commands have a mnemonic or something close. So Control-E is to expose, Control-Y. Y doesn't stand for anything, but it's next to U, which is up. So it's very quirky. That's part of the charm of VI. Yes? Sorry, can you say it again a little bit slower? Swap file already exists. Okay, good. Okay, I got that. So let me see if I can generate that. So I'm editing alice.txt. I'm going to start another session, and I'll edit the same file. I got this warning. It's very common. Yeah, a good question. Thank you for that. So swap file already exists. it gives you a hint right here. Another program may be editing the same file, because when VI starts, it creates a swap file, so it keeps on disk, saves the changes that you're making periodically. It depends on how you have it set up. Or it could be that somebody was editing that file, or you were doing it earlier, and that edit session crashed, so it didn't clean up the swap file, right? So it gives you a few options on the bottom there. You can open the file read-only. You can edit it anyway. You can recover. That means you read in that swap file, any changes that were made in the previous session, or you can quit or abort. So the first thing to do is, do I have another window open somewhere, another connection where I'm editing the same file? If you don't, then it's likely that it's left over from a previous session that wasn't successfully completed, right? So in that case, you have to decide, do you want to recover those changes, or do you want to just get rid of them, right? If you want to get rid of them, you can press E for edit anyway. It's cleanest to remove that swap file, which you can do with the Linux RM command. Those swap files will have a .swp ending. Excellent question. Does that do it for you? Is that all right? Okay, good. Good. All right. So now, paging. Paging is moving a page at a time. Well, here our page is a screen. Our screen is our page. So Control F. Focus. Okay, Control F moves forward a screen full at a time. It's not exactly a whole screen. You see the last line says cupboards? Cupboards and bookshelves. Control F, cupboards and bookshelves, right? So it's almost a screen full at a time, not quite. It gives you a little bit of context at the top and bottom. If you want to scroll forward faster, you can put a number in front of the Control F, like 3, Control F. We'll jump forward 3 screens. Control B will jump you backwards, a screen at a time, or with a multiplier, like 2, Control B, 2 screens at a time. Where do you put the 2? Okay, before. So first you type 2, then you press Control F. So that's the multiplier. And that's a pattern in the VI syntax that you will see this in further examples coming up, where you can do a command, or you can put a multiplier on it, and that command then takes effect over that much more text. Yes? Right. You're right, that's a good point. So, to speed up editing, VI doesn't echo back the commands that you type, right? Which can make it a little bit more challenging for beginners, right? But again, remember, this was designed for a 300 baud line, so to echo back the 2 would add time to the editing session. That's a very good point, though. It's silent. So I just press 3, right? It doesn't do anything. It's waiting for the next thing. 3 what? 3 screens, 3 words, 3 lines. What do you want me to do, right? At this point, I can abort. I can press escape. It aborts the command. There's no visual feedback. You have to know what you're doing, all right? There's a great command called vim tutor. Vim tutor. It comes with most Linux systems. And you can start that up, and it gives you little lessons that you can practice in Vim. Thank you for that. Good question. All right, so there's another way to move in the file, and that's by searching. Okay, so let's say here that I see the word telescope in the middle of the screen. Okay, I want to jump to that word, or to that line. So I type slash, and now I have the slash on the last line, okay? And I can type telescope. Press enter when I'm done, and the cursor jumps to the line that contains telescope. So that's another way to move around in the file. So we have scrolling, we have paging, and we have searching. Yes? Multiple instances. Let's say you want to go to the next instance. You press N. That's short for next. So there's N. Next telescope. Yes. That's a good point. The comment was that's just like less. Okay. So the Vim key bindings have spread into other tools. You find them in many other tools. Question in the back. What about case sensitivity search? Well, by default, the search is case sensitive. You can turn that off. You can make it case insensitive. There's a setting for that. Set, I believe it's IC, short for insensitive case search. So now let's say I search for Alice, all lowercase, right? And it finds Alice, right? Yeah, you can turn that off with set no IC. No insensitive case search. Excellent question. Another question? I'm sorry, I don't think I answered that. You press N. That gives you the N for next. So here I am, I'm at the start of the file. I type telescope, right? And I press enter. And you can see that I'm on line 165 on the bottom right, and it says telescope right in the middle of that line. Okay? Now I'm going to press N, and it jumps a few lines down. If you press, did you get that? Okay, good. Now press Shift N, uppercase N, and it will jump to the previous instance. That's another pattern in VI. A command does something, the uppercase version of it will do kind of the opposite. So for example, N searches for the next match forward, Shift N reverses the direction, next match backwards. Along the same line, notice that slash, the uppercase version of that is question mark. So I can search backwards in the file by typing question mark, telescope, takes me backwards. Now pressing N will take me to the next instance backwards. Okay, so we're still talking about moving around in the file. So let's say I know which line I want to go to. I just wrote a little program, I tried to run it, it told me syntax error, line 10. I want to go to line 10. Yes, a question. What's that? If you're entering a pattern and you want to exit, press escape. Nope, press Control C. I think that did it. I just wasn't patient enough. Just a second, let me try again. Telescope, escape. Yep, that did it. Okay. So escape aborts it, Control C will abort it as well. So that's two ways. Yeah. Control C is a little faster, it seems. Okay, good. Thank you. The word telescope is highlighted. Okay, good. So that's a Vim feature. That's an advanced feature. Set no H, no. Colon no H? That's right. Colon no H, no highlighting. Yeah, to turn that off, I have it mapped in mind to Control L, which is the shortcut for redraw screen. So I have it redraw screen and turn off highlighting. That you can configure Vim, yeah. That's a quick way, yeah. Like slash XXX enter. You don't have XXX in your file. All the highlighting goes away. Right. Yeah. All right. So line 10. I want to go to line 10. So the way I'm going to do that, I'm going to type 10, Shift G. G stands for go to. Okay. So 10. No visual feedback. Oh, whoops. I'm still in the middle of this. Control C. Okay. 10, Shift G. Okay, so now I'm on line 10. Yeah. Oh, okay. Well, it might depend on the exact flavor of Vim or version or the settings, right? So that's fine. Are you saying when you type 10G, it shows you the command you're entering? Yeah. Well, not in my version. But thank you for sharing that. All right, so if you want to jump to the bottom of the file, it's just Shift G without any argument. I'm glad you're following along because I have a lot of information to go through. Yes, please. Control E, like that. Control E to expose the next line on the bottom of the screen. Notice that the cursor stays in its position, right? And this is more efficient. For example, let's say I'm in this file and I want to see what's next, right? What I see people do is scroll down, right? And so far, this is like nothing's happening. They're scrolling down to the bottom of the file, one line at a time, right? It's quite a bit of work, right? And now finally it starts scrolling, right? Well, you can do that a lot faster by using Control E to expose the next line. Question? Is there a command to do what? To show the line numbers? Yeah. Set and new for number. Yeah, there's lots of wonderful options. We won't be able to cover all of them in this tutorial, but that's a very handy one. All right. So let's say you ended up somewhere. Oh, another question. Go ahead. How do you move up half a page? So Control D to scroll down half a page, and Control U to scroll up half a page. Yeah. Yeah. To turn numbers off. So the basic pattern with these setting options, it's a Boolean. So some of them are Boolean and some of them take arguments like values. I should just answer your question. It's no number, right? So the Boolean ones are either on or off. So the pattern is whatever you did to turn it on, to turn it off, just put no in front of the option. Okay, good. All right, I think I'll leave it on because it's kind of handy. All right, so let's say you ended up in the wrong place. I'm going to jump to telescope. Oops. Telescope, and I decide, oh no, I don't actually want to be in here. I want to go back. So to go back, I'm going to press backtick twice. That's the symbol under the tilde. So that's where I was before I jumped. So double backtick. Did you learn something new, sir? Okay, good. Good. All right. So double backtick will jump you back to where you were. So this applies if you go to a particular line you don't want to be there, or if you ended up someplace by searching for text and you don't want to be there. So double backtick will take you back to where you were when you started that action. All right, more about moving about on the screen. You can move to the top of the screen, jump the cursor to the top by pressing Shift H. H stands for high, uppercase H. That takes you to the top. Uppercase L is low. Low. M is middle. So if you see the text and you just want to go to the top or bottom of the screen instead of scrolling through line over line, just jump to the top or jump to the bottom, jump to the middle. The nice thing about the high and low commands is they take a number prefix. So you can say, for example, 4H will take you to the fourth line from the top. 4 Shift H. It's the fourth line from the top. All right. So now I'm going to talk about moving within the line. Quick question, yes? Double backtick and Control I. I'm not familiar with that one. That must be one of those new Vim things. Yeah. Double backtick takes you to the previous location. I haven't mentioned Control I in this session. It must be a Vim thing. Yeah, there's tons of features that were added in Vim. So this presentation is based on VI. Remember, Vim is based on VI. So I figure as a learning path, first learn the original feature set, and then you can learn the bells and whistles. That's what I recommend. That's okay. No worries. Another question. If you want to go to the very start of the file, yeah, I'll show you the Vim because it's better. It's GG, lowercase GG. So just tap G twice and you go to line 1. Yeah. And to go to the bottom of the file, you press Shift G. That takes you to the very bottom of the file. Okay, so now we're going to talk about moving within a line, okay? So I'm going to press W to go to the next word. W goes to the next word. As you can see, it goes to the beginning of the next word. You can press B to go back. Again, a word at a time. Just W for word, and then B for back. B as in Bravo. All right. You can also use E to go to the end of the current word. For example, let's say I want to change that, right, to make it plural. So it's handy to be able to quickly go back to the end of a word. It's very powerful. E for end. Again, those mnemonics. It helps to learn if you learn what the mnemonic is. So let me pick a word with punctuation, like this one, foundation. So I'm going to press E to go to the end of the word, and you see it stops at the punctuation mark, right? You can use Shift E to skip over punctuation marks. So let me go back to the beginning, and I'm going to press Shift E. See, that jumps to the comma as opposed to the N. So the idea there is word versus big word. Big word includes punctuation marks. So how is this useful? Let's say I have two URLs here, and I want to jump over the first one. I want to jump to the end of it. So if I press E, just little e, it stops at punctuation marks. All right? If I press Shift E, it uses big word, which includes punctuation marks. Okay. Again, you can use numeric multipliers. So let's say I want to move two words. I'm going to type 2W. 2W. See, it jumped over web and site. So if you're following along, go ahead and try all of that. You can also move forward just by pressing space, just as you would on a typewriter, for anyone that's used a typewriter. Backspace to go in the other direction. That doesn't replace the HJKL, but it's just another way to do it. Let's say you want to edit a file read-only. Invoke VI as view. Yes, question? How do you redo? Okay, we'll get to that. I hope we'll get to that. I'll just tell you now. Okay. Okay, so first you need to undo something, right? Before you can redo it. Oh, you meant like repeat the last command. Is that what you meant? Okay, good. So let's say that I entered some text, like hello world. Okay, I'm done. I want to undo it. So press U to undo it. But then I changed my mind, and I want to redo it. So I press Control R, and the mnemonic there is redo, and it gives me back the text. Okay, so backspace in command mode means go back a character. That's right. Notice this. It even goes back to the previous line. It might vary depending on your version of VI or Vim or your settings. But just backspace by itself should move backwards within the line. Are you getting that? Okay, you can see me after the session. Press escape a couple of times to make sure you're in command mode. By the way, if you have bell turned on in your terminal, if you're already in command mode and you press escape, it will ring the bell unless you turn it off. That lets you know where you are. So if you get confused whether you're in insert mode or command mode, because earlier versions of VI didn't have the insert mode marker. All right. So now let's get into, I'll skip read only, modifying text. So the command to start modifying text is I for insert. So you press I, you go into insert mode, you can start typing, press escape when you're done, your text is there now. Now there's another way. You can press A to append text, all right? So what's the difference? The difference is insert will insert text at the current cursor position. Append will insert it to the right of the current cursor position. So for example here, would I use insert or append to, what? A little louder. Insert, that's right, insert. So I, insert, N, right? So if I pressed A to append, see it puts the cursor to the right of the current position, right? Okay. Let's say that I want to insert some text, but not on this line. I want to insert it on the next line. The command for that is O. That stands for open a new line. A little louder. Shift O does it above. So if I'm here on new line 2, I press Shift O, it opens the file for editing one line above. Good. All right, so while you're inserting text, you can erase a single character using backspace, a single character. You can erase a whole word by using Control W. Very quick. Or you can erase to the beginning of the line, kill the whole line, with Control U. All right, now here's a fun question. Does it work only in edit mode? Yes. So Control W won't work if you're in command mode to kill a word. And yes? I'm using Linux because I've got Ubuntu under the Microsoft Windows subsystem for Linux. That's what I'm running. Control U. Yeah. While you're in insert mode. Yeah. So an interesting thing about that is here I'm editing a line, and I press Control U. It doesn't kill the whole line, it just kills what I entered. But it kills all of that. Yes. The question was, is there a way to do that without being in insert mode? To do that, I take it you mean kill the whole line. The whole, yes. Okay, so that's actually what we're getting into next, more or less. Let's say that I want to kill from the current cursor position to the front of the line. So I'm going to say D for delete, and then caret for the first non-white space character. Whoops, I was in insert mode. Okay. So again, D caret. So that deletes to the start of the line. If I wanted to delete to the end of the line, I would have typed $. Now D is an operator. It tells them that I'm about to do an operation. I'm going to change some text or edit some text, or I'm going to copy some text to an internal buffer, right? So it's the first one, D. D by itself doesn't do anything because VI is still waiting for you to tell it how much text, right? When you say D caret, it now knows how much text from here to the beginning of the line. Question in the back? Okay. Capital D is a shortcut for $. Capital D is a shortcut for $. So $$ means delete from the current position to the end of the line. Shift D is a shortcut that is equivalent to that. All right, so now I'm going to type 35I, so insert 35 times, and then I'll just give it a couple of characters on a new line, okay? So 35I, and I'll give it a couple of characters, press escape. So first you see the 2 characters, and then it did the multiplication. So that's, if I want to do some little ASCII border, that's a quick way to do that. So I'm going to type 10, open, and then this little pattern, and press escape. Okay, here we go. 10, open. Oops. Sorry. Where am I? Okay, here we go. 10, open. Nope, this one doesn't do it that way. Okay, never mind. We'll skip that one. All right, so deleting text. Okay, delete a single character. What's the command to delete a single character? X. Okay, good. Why X? What's the mnemonic for X? Typewriter. That's right. That's right. So if you wanted to strike out a mistake, you'd backspace, you'd back up, and you'd type X over it, right? Which effectively strikes it out. So VI adopted that. So if you want to delete, in this case, 4 characters, 4X deletes 4 characters. Okay. What's that? DL? Oh, right. So delete and then 1 character to the right. Yes. Okay. Good. Let's say I want to replace that semicolon with a comma. There's a command in VI just for replacing a single character. So that command is R. Replace a word. So I'm going to replace R, comma. Right? Because otherwise you have to go into insert mode. You have to delete it. You have to write the new character. You have to exit insert mode. This is very quick. Just R and whatever is the new character that will replace the character that the cursor is on. Okay, so now let's say that I want to substitute. Instead of replacing 1 character, I'll do a one-to-many replacement. So that's S for substitute. So I press S, it deletes that 1 character, puts me in insert mode. Just a made-up example. Or you can do 3S to substitute 3 words. Little examples. Okay, so once you learn these, all of these, you get really fast. And some people get discouraged, like, there's so much to learn. Well, you don't have to learn all of it in one go. There's tons of materials out there. There's great books, there's tutorials, Vim Tutor, right? Just work at it, you know, post a cheat sheet that you can refer to it, and just work at it. I have a VI tutorial, email me, I'll send you a copy. And it really does speed up your work dramatically if you just invest the time to learn the core features. So we're nearly out of time, because they told me take 45 minutes so that the next speaker has time to set up. So I want to thank you very much for your interest and your participation, all your great questions. And just keep learning. There's tons of materials. Email me. I'm happy to be in communication. Thank you very much. That's the end of the presentation. Thank you. Thank you. Yes? Yeah, I'll put my email back on the screen. Yes, sir. Yeah, that's a good idea. I should post the tutorial on the SCaLE website. I'll arrange that with them. Thanks. Yeah. Vim does have its own settings file. .vimrc is the modern one. Yeah. Good question.
ask questions, comments, jokes, whatever you got. There's only 5 of us. Feel free to do what you need. My name is Jacob Weinstock. I'm going to talk about building some binaries and what we did at NetApp. So here's the basic rundown. The itinerary, we're going to say a little bit about myself, and then we'll get right into it. I'll tell you about our use case. We'll kind of walk through it, what we did, what we ended up with, what we're using now, and then some lessons learned, and then a demo. I got a link here, GitHub repo. This code's up there, so if you want to pull it up right now, you can run it with me, or you can look at it. Hopefully it works. But we'll run in. I'll kind of show you the structure of what we created to help us solve our problems here. So at NetApp, we build a hardware appliance, storage device, and so the team I'm on is a core infrastructure team. We helped the engineers build that. So we help them with the environments. We help them do the testing, network switches, rack and stack, OS configurations. We run the DNS, DHCP services, LDAP, lots of things like that, hypervisors, virtualization. But for this talk, we're going to focus on our situation. So we build a hardware product, and we need to test it. So we got a lot of physical machines that we drive traffic to that storage device. And we also have a large network, so we got a lot of subnets, VLANs all across the board. And so when our developers come and say, hey, all right, we're testing this new feature, and we actually need a whole bunch of nodes, a whole bunch of physical machines, can you move them over to this network? Those requests came into our team. And so this picture here, the colors didn't come out exactly how I expected, but this represents where we were. Yeah, you got a question? Question was whether it's physical or VMs. All physical. Yeah, so we were moving physical machines from one VLAN to another, no virtual type things. Yeah. So I did my best here to show what our previous state was. So all the square boxes represent either a process or an application or something that when we got a request we had to go interact with. And the colors were supposed to represent that there were different ones. So like the 2 on the end are actually different even though they look like the same color. Pretty much all of them are different colors. And so we were having to, a single person would get a request in and they had to go to all these different applications and they had to follow different flows in each of them, you know, maybe some code reviews here and there, or you know, this network team section here, we had to hand off to them so that they could update VLANs on switches. And there's a lot of back and forth. So there was lead time, then there was actual process time. There was a lot of stuff going on, right? So we were being impacted in our business, right? It was taking our team to move. We had a use case where we had 20 physical machines came in, a request to move them to a different VLAN, and it took 3 of us 3 days to do it. So, you know, walking through all of this, it wasn't, you know, if we had the access and authorization to do all of this, yeah, maybe it would have taken a couple hours, an hour, or something like that. But, you know, a couple handoffs here and there. For example, going from this second little square to the third one to the network team, that's another handoff. Wait for that team. What does their workload look like, right? And then if you look at this box that says update puppet code, there's a whole process in there. We had to write the code, and you had to test it, and you had to put it to a staging branch. You had to run its CI, CD stuff, and then it had to get merged to a production branch, and then that had to get out to the actual puppet master. So, I mean, that's just one box, right? That process right there, depending on how many times you need to iterate through that, could take you a day or 2. But again, on average, it was taking us about 3 days. Pretty bad. So we were really impacting our end users, the internal engineers. So features were getting delayed quite a bit. So this was the task. Can we do this? Can we change the way things are running, are working? Can we change the process to make it easier? One team can maybe do all of this, and then ideally, right, just one process does this, right? can we abstract all the complexity of moving from, you know, our IPAM solution to a network device to a Puppet config? Can we abstract that out? Can we? And then obviously the biggest driver was we need to decrease this time. We need to be able to move machines between VLANs. We need to do it like that. And then if possible, we wanted to create something that was easy and self-service. Ideally, being lazy operations engineers, we wanted someone else to do it, so they could take this, you know, service and they could just run it, and it would move their physical machine to a different VLAN. That was the goal, right? And we had some constraints, and here are just a few of them, right? Our team skill set, right? We were 90% operations engineers. Didn't have a lot of development experience. We had a really short 12-week delivery time, and that's from nothing to like a working product. We hadn't architected it, we hadn't done anything. We were given 12 weeks though. And then we couldn't install anything. So these physical machines that we had, they were specific to our testing infrastructure, and they needed to drive I/O to our storage devices. And so they had configuration, they had apps and things on there. And we weren't allowed to really mess with those. And if we did, we had to change it back to what it was, and we didn't know what that was. So we kind of put a hard constraint on ourselves.